Hey up, it's Steve from the Old Yorkshire Geek, and welcome. We're having another go at watching SpaceX launch their Starship rocket and booster. This is the integrated flight test number 3. So we're going to have another go at see if they make it this time. The first time, exploded before it reached orbit. I think the second one just about reached orbit, and then there was some problem, and they blew it up, or it blew up. Can't remember which. Now we're going to try again, third time lucky, hopefully. Right, so I'm watching the NASA spaceflight feed. I've put the link in the description. I'll also be watching the official SpaceX feed. So let's see what's happening, shall we? Where have I put it? There we go. Let's get rid of the chat. I don't want to see the chat, do we? There we go. Right, so this is what's happening at Boca Chica right now. Let's go full screen. There we go. And apparently they've put the launch back. And I'll get out of full screen and see what they say on the SpaceX Twitter. Let's give that a refresh. What are they saying? Here we go. The Starship team is go for propellant load, but keeping an eye on winds. Now targeting 8:25 a.m. So it's another bloody hour away. Unbelievable. Central Time for liftoff. So they're loading the propellant into the as they say, vehicle. By the way, on the screen behind me, there's the NASA spaceflight feed. As I said, the links are in the description for that, and the SpaceX feed, and the SpaceX X X page, whatever you want to call it, Twitter, all that. Windgrace says, I hope the Vulcans are in the vicinity. Zephram Cochrane sitting atop that with LaForge and Commander Riker getting ready with their I've got the name of the bloody song now, with his little green CD. Magic Carpet Ride with that song. Getting ready. Anyway, so there's a big tower vent there, isn't there? So the load of all this stuff's normal, I think. I'm not an expert on all this stuff, but the propellant is being loaded. The booster, which is below, propellant gets loaded through that there. It's got a name for it, and I can't remember. I'm blanking. And the Starship rocket on top has got its own pipe feed. They pushed it back now because he couldn't find the disc. Yes. And he had to take a leak. Don't you people in the 24th century pee? That'll do, pig. That'll do. Oh dear. Oh, never mind. I'm gonna say something about Babe, but never mind. Don't matter. So there we go. This is that's the SpaceX feed. Obviously, let's give that a refresh because they've updated the launch time. So 12:52. This feed's gonna start. Let's give the Twitter feed a refresh, see if there's anything else. No new updates. Right, let's go back to this one. Also, it's not going to splash down off Hawaii anymore. It's going to splash down in the Indian Ocean. So it's like going about halfway. But it's still going to reach orbital altitude. But it's technically not in orbit. But it's going to get to that altitude. So it's like a suborbital flight, but it's going to reach orbital altitude. I presume orbital speed as well. But it's not actually going all the way around. So that's if it works. I mean, we could get a scrub. You never know. They keep pushing it back, don't they? They keep pushing it back. It was supposed to launch, I think, at about 7:30 local time. But they keep pushing it back. So I wouldn't be surprised if there's a scrub and we have to wait a day or two for another test flight. We will see. Right, let's see what the chaps at NASA Spaceflight are saying. I'll mute myself and I'll put the volume on.
Be expected to. So that is kind of the mission profile here. They're going to be demonstrating the opening of Starship's cargo doors. That'll be important for SpaceX so they can start launching their larger Starlink satellites on this system soon, but also, of course, for NASA, who is going to be depending on a variant of Starship to land on the moon. And Adrian, one of the things they'll be demonstrating in orbit is a fuel transfer. Why is that important to demonstrate?
Well, it's important to demonstrate because refueling in orbit is essentially a fuel transfer, and refueling in orbit is one of the important capabilities they need to get the HLS, the Human Landing System, ready for the Artemis missions. So essentially what they will do here is most likely transfer fuel between the main tank and the header tanks, so they can just understand a bit better how to transfer cryogenic fuel. Down the line, they need to do this between ships, because what they want to do is they want to launch multiple tankers, use these tankers to probably tank up a depot, and then that depot will be used to tank up the HLS lander for the moon. So they need this capability. They need to understand cryogenic transfer in orbit, and that's why they want to test it, so they just get better understanding here. And I'm just looking at the vents here right now. So based on the timeline, we are at closing in into T-minus 53 minutes, which, if this is still the goal, should be the moment where the tower vent goes off. Because the tower vent is the indicator of ship loading, and ship loading should start at T-minus 53 minutes. So we should be 15 seconds away or so from tower vent stopping.
We'll see how accurate our clock is here too. So,
yep.
and because and I want to make clear to the audience why we're speculating is because we don't have a feed from SpaceX as to what's going on behind the scenes. And what we're looking at here are NSF's own cameras that are situated throughout the entire area of Starbase here. And we're able to see what's happening so that we can report to you what's going on. And what we've been finding is that Alex and Adrian here have been predicting slips in the launch schedule here because of what we're seeing or not seeing here on the pad. So I'm seeing, of course, a lot of venting coming out of the middle of the tower. Alex, what does that indicate?
Yeah, and I should say this is not an exact science, right? Sometimes there's still some leftover things that they need to vent out of that tower. So even though, especially if they start with a slow fill kind of thing, I can imagine that it doesn't do a one-to-one kind of correlation of whenever the tower vent actually goes out and disappears, then that's when they load. It is usually an indicator of that, but sometimes, in reality, the actual flow of that liquid oxygen may be that it has already been going into the ship for a couple of minutes prior to that. We see a similar thing with the Falcon 9, where even when they start the liquid oxygen load on the second stage.
Sorry, I'll just shut him up a minute. I just want to show, Windgrace just mentioned this. Oh, no, gone too far. Japan just exploded their attempts, so I hope this Go 3 is better. He's very modern, is Windgrace. Uses numbers in his text, because he's one of the kids, he's hip, is Windgrace. Maybe they had tacos last night, I need to vent it out. Yes, anyway, this one. I just thought I'll show you this, so just get rid of that and we'll have a look at this rocket exploding in Japan, because it's quite spectacular. Right, so this is from the BBC. There we go. So let's see what happens. The full screen. My fingers there. Ooh! An IUD, rapid unexpected disassembly. Oh, hope there's nobody down there. Call international rescue. All the tanks blowing up and everything. Oh dear. So it's spectacular, but kind of sad. So there we go. So that's what happened in Japan a few days ago. When was it? Space One's.
It's kind of a source of entertainment. Sometimes it's
automatically doing things. Never mind. Space One's Kairos rocket burst into flames shortly after liftoff in western Japan on Wednesday. The explosion left a large plume of smoke in the air and sent fiery debris flying near the launch pad. The Tokyo startup was racing to become Japan's first private company to put a satellite in orbit. Yes, because it's the Japanese space agency's JAXA, in it, which is cool. Cool initials, JAXA. It's nearly as good as Roscosmos, which is the Russian one. Right, back to these chaps. Right, so I'll go see what they're saying. Let's go full screen. And
what we're looking for now is that frost to build up on the outside of Starship.
Yep, the upper stage is now loading. Again, they start the liquid oxygen load first and then the liquid methane load 2 minutes later. The first thing we would see is the frost ring at the bottom, close to the ship QD. You can see the ship QD there going from the tower to the ship. And right at that area, we will see a frost ring forming very, very soon. That's basically the area of interest right now, where we are having a close eye on, because that's the first frost ring that will appear on this vehicle. And it actually should appear any second now. That's at least my expectation. Like, usually this goes pretty fast. Once they are going into fueling, this basically happens in minutes.
And
yeah, we'll just start
Alex,
seeing that frost soon.
Alex, what does this mean for the tiles on the outside? Because we're going to see the frost build up, obviously across the entire Starship. But you know, the top of the rocket, which is what's facing us here, which will be the top when it gets into orbit. The top is just stainless steel, essentially. We'll see the frost build up there. The temperature change on the surface.
Oh, it's taking it off now. That thing in the foreground was Starhopper. It's one of the test things for the Raptor engines. See if they could take it off and land. So that was a test thing. So I think they use it as like a water tank or something now, I think. But anyway.
Freezing.
Yeah, it is indeed quite a challenge. And then when you have the re-entry, you have on one side the cold tank, and on the other side you have blazing hot plasma, right, heating up the tiles. So you not only have a sort of gradient of temperature over time as you load that cold propellant, but also even in physical, in like the physical state of the tile. On one side is super cold, and on the other side is super heat up. So it is quite a complicated challenge in engineering wise, right? And so
I have no idea what a Nixon build-up is. I have no idea what that is. But I'll take your word for it, Wingrace. Oh, there's Starhopper. So see its legs there. We're watching we're looking at the bottom of the super heavy booster. Oh, there's the Starship fuel lines. It's got a name. I've forgotten. I don't know. It's not crew access, but I don't know. Fuel access arm. I don't know. They've got funny names for them, haven't they? And then we can just see the chopsticks, which obviously are used to lift the rocket onto the orbital launch mount. And fingers crossed, in the future, it'll be used to catch landing starships and boosters. The hope. I bet they don't. I bet they don't. But you never know. You never know. It'll be cool if they do. Because I'm a hip young kid, I was making a Frost Nixon joke. Oh, right, okay. Very good. I never saw it. I've never seen the film, and obviously I know about the interview with David Frost and Richard Nixon, but I've never seen it, and I don't know anything about it. Whether a big build-up to it, I don't know. A hip young kid. That was decades before you were born. Well, just about. Oh dear. Look, we can't see the bloody ship now for all the venting methane and all that jazz. And liquid oxygen. LOX. Is it oxygen? I can't remember what they've got. I think it's methane and liquid oxygen they use in it, I think. But it's very cloudy there at Boca Chica today. In Texas. Yeehaw! It's just about in Mexico, isn't it? It's just about in Mexico. It's not far from the Mexican border. But they've got to fight off Mexicans trying to get into the US. Oh, dear. There's the Starship fueling point. Can we see any frost yet? I can't see any frost. Oh, Frost Nixon, yes. Frost Nixon. Yes, I can't see any frost yet on the Starship. But that was interesting what they said, that they're going to test out the payload delivery doors. Because the showers further up the ship. It's got the payload doors on it. It's not like on the shuttle with the big massive doors. It's like a slot that it's supposed to like shoot out, like a toaster, supposed to shoot out like Starlink satellites and stuff. But I still can't see any frost, so I bet they push it back again. I bet they do. Let's get out a full screen and check. On the X feed, no, it still says 8:25. Right, fair enough. Which is how far away? About 45 minutes. Or thereabouts. Right, we'll have a listen to them again. So I'll shut myself up.
Indication that the ship load hasn't started, and then they tweeted about it, so we are gonna wait for that. But I'm gonna answer your question here about the flights over Brownsville should be good, because the TFRs, the temporary flight restrictions, and basically all the NOTAMs, the notice to air missions, those are over mostly over the ocean and over the launch site. So Brownsville, fortunately, is far enough away, at least, that it is not within that area, that zone, so those should be good to go. And frankly, probably Brownsville Airport, it's not a busy airport, but they're probably thankful that it doesn't cover their airport like on other. And there we go. We just got the confirmation. Propellant load of Super Heavy Booster is underway. So
can we go to the ship? Can we go to the ship? Yeah, to the close up on the ship QD, please, if that's possible. I see a frost ring, I think.
That's it. QD, quick.
Yes, there it is.
There it is.
Liquid oxygen is being loaded. Liquid oxygen is being loaded onto Starship.
We get very excited about frost and venting here on on NSF, because it is an indicator that things are moving in the right direction. So what's happening right now? Boosters getting fueled and shipped?
Yep.
Yes.
Both are being loaded right now, which is great news.
And Adrian, how long does it take to get the fuel in? Because that's obviously a factor here in making sure you hit the window.
It's an interesting, because the OLM vent, and that's what Alex kind of hinted at, that these venting stopping and everything is a bit of a it's an interesting indicator, but not always perfectly lining up. Because, for example, the OLM vent here stopped way earlier than actually where they would start booster propellant loading, because it stopped around 43, 44 minutes, but actually they don't start until 42. So if this time at the top is still correct, and I believe it is, they are now progressing still to this estimated T0, and it takes 53 minutes for the ship from basically propellant loading to T0, and they will start the boost at 42 minutes. So this is where we are right now. So both stages are now being loaded.
And even if they're not certain they can get off... Sorry, go ahead, Alex.
Yeah, I was going to highlight what you said, Adrian, that it looks like they may have tweaked a bit here at the start of these loadings on both vehicles. It is pretty much still what they have published, but just off by a few minutes here and there. And based on the previous, it's completely normal though that when based on the previous data and the previous flight, and there's also a new tank farm, right, with all of those new additions and things like that they tweak these things much closer to the liftoff, and so not unexpected to see this. We saw a similar thing with Flight 1 and Flight 2, where some of the timings did not correlate with what they had put on their website, mostly probably because again they try to go and tweak those things as just in the fly, not really, because it's on the ground, but you know what I mean.
All right, and we are looking at Starship Flight 3 in fueling mode right now. So we are about 40 minutes from what SpaceX says is the T0 launch time. They still have some margin in the launch window here, which extended from 7 a.m. Central Time to about 8:50 a.m. Central Time, if I'm not mistaken, if my math is correct, 110 minutes. The fog you are seeing there is from fueling mostly. It was a very foggy morning. That fog has dissipated, but now we've got space fog generating from ship as it gets fueled. We've got super chilled fuels going in. We've got humid air. So just like a soda can, you're going to see ice building up and condensation all around. It's going to look pretty cool. There's a nice cloud on the ground that we saw from some drone shots on Ship 2 that we watched not too long ago. So that is what's happening. We are feeling pretty confident that SpaceX is going to try to push to launch here because they are fueling the rocket. It does take some time to do that. And Alex, we got an update?
Looks like the booster is already frosty. I see some frost lines. There you go. Thank you, operator.
Yep, there we go.
Some frost line on the methane tank. I'm mostly sure that the oxygen tank is also frosty. The problem is lower down in the booster sort of structure. There's all of the tank farm and everything in the way, so we'll probably have to wait a little bit more until that frost grows and be able to see that frost on the liquid oxygen tank. But most definitely probably already there. And also frost on the methane tank on the ship as well. You can see there frost on each of the tanks. So we have all of the 4 main tanks of Starship Super Heavy completely well underway in that propellant load sequence. Frosty, and they're gonna get even more frosty as they get more and more propellant on board.
As they get more further along. And this is something, by the way, that SpaceX has a lot of experience with now. Although they've only launched this stack 3 times, they have fueled these stacks many more times than that. So this is becoming part of, I don't want to say the routine, but it's becoming something that SpaceX has got a good understanding of, and they're really honing in the speed in which they can fuel.
I'll just interrupt because we're talking boring stuff about fueling and things. I'm going to go back because earlier on, I think before I started the stream, they showed some comparisons how big this rocket actually is. So I'm going to show you that if I can find it. Oh, there we go. Is that one of them? No, that's just showing. Where's that one? That's showing, the tower, OLM vent, LOX subcoolers. But they showed. There we go. They showed a diagram as to how big it is. Is it going to show it? There we go. That's what we're seeing today. That's the. Let me pause it. That's a Starship with a super heavy booster and the Starship on top. That's how big it's compared to the SLS, which has launched successfully already, hasn't it? SLS-1 launched successfully, got its capsule to the moon and all that. That's Ares-1. That's the Electron rocket. That's the space shuttle. See, it's a lot bigger than the space shuttle, and that's Falcon 9. Is Falcon 9 the most successful, rocket ever made? Don't know. Could be. Factoid. Tom Cruise will be riding on the outside of the ship and diving off once it reaches the cusp of space as part of filming for the new Mission Impossible. You know what? I wouldn't be surprised. He'd be doing a Slim Pickens riding that rocket. Oh dear. So there we go. And they also show how big it is compared to some buildings and stuff. Hang on, see if I can find it. Where are we? It's here somewhere. Where is it? Well, I thought it did. Unless, there we go. Let's go back to that again. Right, it's showing that how big it's compared to the other rockets, and how big it is compared to some buildings. I'm just bloody seeing it. Where is it? I'm just bloody. There we go. Pause. Oh, it's just bloody gone off. Go back 5 seconds. There we go. Right. That's the rocket. That's the Starship. That's compared to the Queen Elizabeth Tower. Get it right, NASA space flight. Big Ben's the bell. It's the Queen Elizabeth Tower, Statue of Liberty, the Great Pyramid at Giza, which I've seen 2 of these in real life. I've seen not Big Ben, the Queen Elizabeth Tower, and I've seen the Great Pyramid of Giza. Not seen the Statue of Liberty in real life. But it's just a little bit shorter than the Great Pyramid, so it's rubbish. And then they show it compared to some skyscrapers. There we go. Empire State Building, there we go. Little teeny tiny little SpaceX Starship rocket there compared to the new World Trade Center Empire State Building. The Shard with the Eye of Sauron on top, which is in London, and the Eiffel Tower being up part of it, not to the very top. So there we go. Just thought I'd share that with you. Right, let's go live again. Oh, press the wrong button.
it's usually called in
Anyway.
the industry the minimum.
So all of these buildings are also
where
secret spacecraft.
sort of
Yes, they are. Just like
what else is needed to at least
that
get
building in
minimum,
Stargate that they
available
transported
to
into
do
space.
something, right?
It
In this
inadvertently
case, the
became a
something
spaceship
is
before it blew
get
up.
some data back, right? It is a really
Oh, dear.
complex vehicle. Trying to develop this
That barley.
in a more traditional manner where you spend long time to be able to, analyze
We're
everything.
still seeing the
That will
fueling.
take a huge
Let's
amount
see if they're still
of
targeting
time, a huge amount
825.
of
Let's
money.
see what it says.
That time and
On
money
the
instead will be
SpaceX
spent
X
on,
feed.
doing some
Yes,
analysis.
still
It's not
targeting
like you're gonna be doing
8:25
analysis, of course,
AM,
but
which is, what
helping
time is it
those
now?
analysis by
12:50,
taking
so
real life data.
35 minutes
Sometimes you
away.
have models and things like that, but having actual flight data, having actual real life data can help a lot inform those models. And so it is a very nice thing to have when you have such a complex vehicle such as a Starship, especially in the future when it's supposed to be fully reusable and everything. It's really good to have that capability of being able to try to do trial and error and trying to find the weak points of your system using that, because sometimes models can miss a lot of these things. It is complicated to go through every single detail and not miss something. And so when it is a much smaller rocket, a much simpler rocket, and especially one like Vulcan that draws upon a lot of the heritage from Atlas and Delta, it is much easier to be able to go through the traditional route where you take a little bit more time with those models, and then your first flight obviously succeeds because it draws upon that a lot of time and a lot of heritage. Whereas these, you kind of, the failures are a feature of the test campaign, right? Of trying to develop this rocket rather than a bug. So yeah.
And it looks like we're still moving along here. We are about just under 33 minutes from the T0 announced time from SpaceX, and a lot of indicators are here that we're going to be pushing for this launch today. The fueling process is continuing. Adrian, I see that frost ring climbing up the side of the rocket. That means we're getting more fuel inside, doesn't it?
Yeah, and absolutely. And one of the next big steps that we are looking for at a not fully defined time, and actually an interesting part about Starship is the fact that they will open the OLM hold down clamps, because with some other rockets you have the engine throttle up, and at some point the rocket computer, the onboard computer verifies go, and then clamps open, right? That's not the case with Starship. Starship, as we understand it, and this is like, there's also a bit of like reading into the countdown in here, is in a situation where you basically have the clamps will open at a certain time way before liftoff, and from that moment the rocket just stands on the pad. It's basically just secured by its own weight on the pad. And at the minus 3 second mark, the Raptors will throttle up, and we will basically they will still have a thrust to weight ratio of under 1 until T minus 0, basically the moment where they will start to ramp up the engines. And the whole point of about T plus 2 seconds being liftoff, that's just the moment where the Raptor throttle up reaches a thrust to weight ratio of over 1. Because this rocket, again, there's no clamps. As soon as it has a thrust to weight ratio of over 1.0, it just goes.
It's physics. And you know what? That's one less.
Science. Right, see if the SpaceX feed has begun. So, not going to that. Let's refresh it. Refresh it and see if we're going. No, it isn't. Supposed to have started. You're late. You're late, SpaceX. You're rubbish. Oh, it is going. Unbelievable. Why can't I hear him? Oh, maybe because it's muted. Unmute.
Goal is to collect as much data as possible, and that'll help us get one step closer to a fully operational Starship. Now, Starship, which you see on your screen, is the latest and largest vehicle developed to date by SpaceX and in the world ever. Compared to Saturn V, the rocket that first took astronauts to the moon, Starship has more than twice the thrust, and with some upgrades that are planned for the future, it'll have 3 times the thrust.
Starship will allow us to fly the heaviest payloads ever flown land humans on the moon again after more than a half century, and ultimately fly humans further into space than ever before, even to Mars. But the most important thing about Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we like to call the 4 Rs. And we'll talk more about those later in the webcast. But before we dive into the details of today's test, let's recap the achievements of our last integrated flight test, Flight 2. All 33 Raptor engines on the Super Heavy booster started up successfully and, for the first time, completed a full duration burn during ascent. As you can see here, we saw amazing views of each Raptor engine burning during that ascent, which is something awesome because we don't get to see that with Falcon and its Merlin engines.
Now, next, Starship executed a successful hot stage separation, powering down all but 3 of Super Heavy's Raptor engines and successfully igniting the 6 second stage Raptor engines before the vehicle separated. This is the first time this technique has been done successfully with a vehicle of this size and scale.
Following separation, the Super Heavy booster successfully performed its flip maneuver and initiated the boost back burn. However, about 30 seconds into that burn, it experienced a rapid unscheduled disassembly, or RUD. That's SpaceX speak for an exciting end to the booster's journey. The likely cause was determined to be filter blockage, where liquid oxygen is supplied to the engines. So we've upgraded hardware inside the oxygen tank to improve filtration capabilities in our boosters, including the one that's out on the pad today. Vehicle breakup occurred more than 3.5 minutes into the flight, about 90 kilometers over the Gulf of Mexico, so well away from people.
Now, on Starship, the 6 second stage Raptor engines all started successfully at separation, and everything was going normally in the ship's climb to space until about 7 minutes into the flight, when we began a planned vent of excess liquid oxygen propellant. To simulate the mass of a payload and get future-focused data, the ship was loaded with extra propellant that we needed to get rid of or vent before re-entry. Once we started venting, though, a leak developed that caused fires, which eventually cut the connection between the flight computers on the ship, and that caused the 6 Raptor engines to shut down before we had finished the full burn. That was detected as a mission rule violation by the Autonomous Flight Safety System, which triggered the flight termination system and led to vehicle breakup.
Starship's second flight test nearly completed its full duration burn. It ended at an altitude of about 150 kilometers and a velocity of 24,000 kilometers per hour, officially making it the first Starship to reach outer space. Like the booster, we've made upgrades to Starship's upper stage based on Flight 2 learning, such as improved leak reduction, fire protection, and changing the operations to increase reliability.
Now, back at the launch site, the new water-cooled flame deflector and other pad upgrades performed as expected, so the pad required minimal post-launch rework. And that's a big reason why we are ready to fly again today. The ground support systems are designed for rapid turnaround of the launch pad between flights, and the improvements we've made ahead of Flight 3 are getting us closer to that goal. And that brings us to today's test. The test profile and the burn timeline are very similar to test number 2, with one major difference. The ship will attempt to splash down in the Indian Ocean rather than the Pacific. This puts us on a steeper trajectory than past flights and lets us test capabilities that we'll need for the future, like lighting a Raptor in space while maximizing public safety. So let's take a closer look at the flight test profile. Now, about 26 minutes from now, Super Heavy will ignite its 33 Raptor engines and lift off from Starbase. About 3 minutes into the flight, Super Heavy's booster will separate from the ship in SpaceX's second ever attempt at a hot stage separation. That means it'll light its engines while still attached to a partially lit booster. The ship's engines will then remain lit for about 6 minutes during the ascent before entering a coast phase.
Next, the booster will perform a flip maneuver and execute a boost back burn, which, if you recall, is where Flight 2 Super Heavy experienced a rapid unscheduled disassembly. We're hoping hardware upgrades made for this flight will get the booster closer to executing a landing burn in the Gulf of Mexico. In the meantime, Starship will coast for about 30 minutes at altitudes between 150 and 235 kilometers, and the ship will attempt to fire a single Raptor engine for our first ever relight of a Raptor engine in space. And from there, the ship will head toward its destination, splashdown location in the Indian Ocean. Again, if we get past a successful stage separation and a full ascent burn with the upper stage, It will be at an added altitude and trajectory below orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn, and it will naturally come back into the atmosphere no matter what.
Now, meanwhile, the Super Heavy is going to attempt a landing burn before splashing down into the Gulf. And while we are going to practice a landing, we aren't planning to recover any of the hardware from Super Heavy or the ship on this flight. Now, with the exception of Falcon, this is no different from what happens with most rockets flying today that are expended or fall into the ocean after they complete their mission. Eventually, though, we will land and recover Starship boosters and ships, just as we do with Falcon 9 and Heavy boosters, where we've recovered 283 to date. Starship's rapid reusability is key as we begin missions to the moon and beyond.
Even though recovery is not planned, the telemetry and data we receive all the way to the end is what we're looking for, particularly with regard to the ship's temperatures during reentry and how the heat shield will perform. The data that we gather today, of course, will help us continue to build a rapidly reusable Starship for the future. Now, much like our first 2 flight tests, today also still just a test. Our goal is to gather data to continue iterating and ultimately improve Starship.
That's exactly right. The primary goal for Flight 1 was to clear the pad, and we did that and got a lot of great data that helped us improve the vehicle and the pad infrastructure that you see today. The primary goal of Flight 2 was to get all the way to stage separation, which we did, and even got a little extra.
For Flight 3, we've added some ambitious tests highlighted by an attempt to transfer several tons of propellant between the tanks inside Starship itself, as well as the first ever relight of a Raptor engine in space and the opening and closing of Starship's payload door. When Starship takes astronauts to the lunar surface as part of NASA's Artemis program, it will be refilled in space by a Starship tanker spacecraft before boosting itself into a lunar orbit, like you see here. Transferring a large amount of cryogenic liquid in space has never been done by anyone, ever. So we'll be looking to get data on some of the fundamental physics in play here, like managing pressures, temperatures, propellant settling, all as we prepare for eventual ship-to-ship transfers. The ability to refill Starships once in orbit will be critical for landing on the moon and is a key technology for enabling deep space exploration and ultimately flights to Mars.
Now, we're also attempting the first ever relight of a Raptor engine in space, and we'll need that capability for future in-space maneuvers and deorbit burns. It's important to note that what we'll attempt today is not a burn required for Starship to re-enter on today's test. We are intentionally flying this new steeper trajectory so we can test things like engine relights without substantially changing where we expect to splash down. And if Starship manages to make it all the way to re-entry, we will collect valuable data on the vehicle as it flies through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. We expect it'll look something like this animation on your screen with the heat shield tiles facing down. We'll use the Earth's atmosphere to brake the vehicle and then get us into a controllable regime as we go towards splashdown. Now, we did validate Starship's ability to fly and land at subsonic speeds during our suborbital flights several years ago, and gathering data on the aspects like heating and vehicle control while we're traveling way faster will become critical to eventually bringing Starships back from space for rapid reuse.
We'll also attempt to open and close Starship's payload door for the very first time, a capability that we'll need when Starship starts flying our next generation Starlink satellites. And there you can see an animation of what that will look like as the satellites are deployed one by one through a slot near the top of the spacecraft. So at this point in time, we are approaching T-minus 21 minutes until liftoff. Let's check in with Dan for a countdown update.
Hey, thanks, Kate. Hey, everybody. I'm Dan Hewitt. Good morning. Welcome to Starbase. I'm coming to you from the Raptor's Nest, where I'm here with some of our flight controllers, also our Pad Red team. We're just behind the Mega Bay. Those are Super Heavy boosters right behind.
Just shut him up for a minute. They're not mentioning that originally they're supposed to be dropping, landing or doing a soft water landing off Hawaii. Now they're just going to let it just splash into the sea, aren't they? But never mind that. Anyway, we can go to Starship and the next generation in the same sentence. Yes. Spooky.
The other big watch item today is going to be the winds. The winds have started to pick up. We're still looking to be below our limits, but there could be a hold at T-minus 40 seconds just to make sure that the winds are acceptable before we go. We are actively loading propellant on board the vehicle. You can see by the frost line starting to build up. Looks like we're about 80% on the ship main tanks right now and a little over 60% on the booster. Now, Starship uses liquid methane as its fuel, liquid oxygen as its oxidizer. Both of those get cooled down to cryogenic temperatures, so several hundred degrees below zero. And if you followed along with our previous 2 flight tests, the prop load timeline today looks a little bit different. Those first flight tests, it took us about 90 minutes to load all of the prop on board. But since the second flight, we made some pretty significant upgrades to make that time shorter. We added right around T-minus 42 minutes. We are about to pause loading on the main tanks of ship, switch over to the header tanks, and then switch back to close out the main tanks. We're expecting all of the prop to be on ship at about T-minus 3 minutes 30 seconds, and then booster prop load ends at T-minus 2 minutes and 50 seconds. Now our final countdown and startup sequence is going to be the same as Flight 2. We already tested this on this booster when we did its static fire. Looking back for Flight 1, we lit those Raptor engines on the booster and lifted off about 6 seconds later. Flight 2, we reduced that time by almost 2 seconds. That just helps reduce the stress on the ground systems, improve the efficiency of the rocket. But right now, we're just about to pass 18 minutes away from launch. Winds, again, they're still looking a little bit marginal, so we'll keep an eye on those. We're not working any other technical issues, and the range is expected to be green. If we can't make our test today, we have backup launch opportunities in the coming days. Could be 24 to 48 hours, all just depends on how far we get into the count. So check back in with everybody in just a little bit. For now, though, I'm going to send it back to Kate and Shiva out at Hawthorne.
Thanks, Dan. The countdown is continuing to progress, so let's take a closer look at the world's most powerful launch vehicle ever developed. Starship is comprised of 2 elements, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Starship is capable of about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will actually be 3 times more powerful.
Now, with those future improvements, that'll allow Starship to carry somewhere between 150 and 250 metric tons to orbit, depending on the configuration. For reference, Falcon 9's heaviest payload to date is just over 17 metric tons. So with Starship, we're talking about an order of magnitude greater in terms of payload capability to orbit. And that matters because the amount of mass we're able to launch per rocket is critical to creating a self-sustaining city on Mars.
In terms of size, the Super Heavy booster alone stands about 71 meters or 233 feet tall and is about the same height as a fully integrated Falcon 9. The ship stands about 50 meters or 160 feet tall. Stacked together, the booster and the ship are by far taller than the Statue of Liberty, which stands at 305 feet tall with its base. Stacked together, Starship is 396 feet, so quite a bit taller there.
Now, Starship's first stage has a diameter that's about 2.5 times that of Falcon 9, and when we've got those 33 much larger Raptor engines, this great view of the launch mount looking up at those engines, and we need them to power through the Earth's atmosphere and gravity to deliver those massive cargo and payloads up to space. Moving up the rocket, Starship is designed for vertical takeoff and landing on any hard surface, and that's as opposed to taking off and landing on a runway as aircraft do. And that's important because there are no runways on the Moon and Mars where we're going. The ship, which we're looking at now, features 6 Raptor engines. 3 of them are sea-level engines, 3 of them are vacuum engines. That means that those vacuum engines are optimized with a larger engine nozzle to operate in the vacuum of space and get us higher performance.
The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing. The body of Starship is also wrapped in a heat shield made up of 18,000 hexagonal ceramic tiles. Those are designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. One of our test objectives today is to verify how Starship systems and thermal protection system tiles perform during reentry. And in between the first and second stages is our hot stage, which is critical for our newest separation technique, which we saw in action during flight test 2.
Yeah, that was a pretty exciting first for our team. Hot staging had never been done before as part of a reusable space transportation system, let alone on a vehicle with the size and power of Starship. Now, at about liftoff plus 2.5 minutes, the booster shut down most of its 33 engines, leaving just 3 of them running. And then the ship simultaneously ignited all 6 of its engines. Some clamps separated and the ship thrusted away. That was the first in-flight test of the heat shield, and we were able to gather a ton of valuable data about hot staging.
We maximized the vehicle's performance by leaving 3 first stage engines on, so gravity can't rob us of precious velocity, or at least not as much. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the propellant tanks, which is where we need them to be in order to quickly light the ship's engines. It also reduces risk at stage separation because it creates a passive staging system so that physics will be doing the work instead of mechanical parts pushing the 2 stages away from each other. Ultimately, hot staging could increase Starship's payload to orbit capacity by 10%, which directly translates to more payload and more people to the Moon and Mars.
Now, the first stop will be the Moon, and the SpaceX team has been hard at work proving out all of the systems necessary to make that possible. Critical systems for propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatches down to the lunar surface, are currently in development. And the data that we gather from each test flight helps inform their design. Here we've got a photo of some of the mock-up suits that are used to demonstrate the range of mobility that astronauts will be expected to have. And we were using these to do human factors demonstrations and figure out the layout of the elevator. So all awesome development work for a future moon mission.
Super cool. Now, SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. There's so much to look forward to. It's incredible that humans are finally going back to the moon.
You couldn't have said it better, Kate. And the moon is just the proving ground. It's just the start. When the time comes to make the leap to Mars, everything ramps up by orders of magnitude. The logistics of supporting an entire city on Mars are daunting and will require millions of pounds of cargo flown from Earth and spread out over thousands of launches.
And today's flight test is one more step toward that ultimate goal. We're currently at T minus 11 minutes, 47 seconds. Let's check in with Dan once again for a countdown update.
Hey, Kate. Still good news from down here at Starbase. We're not tracking any technical issues that are going to block us to a launch. Our T0 time still holding to 8:25 a.m. Central, so just about 11 and a half minutes from now. The real thing we're going to keep an eye on is the winds once we get there. We do have that potential hold at T minus 40 seconds where we can hang out and either let winds die down, make sure we're in the right structural limits, everything like that. So don't be surprised if we do a hold at T minus 40. We've done those on previous flights, but we are not tracking any technical issues. The range is going to be green for launch, so all that really great news. We're still loading propellant on the vehicle, on the ship. We're just about done loading the header tanks, the 2 smaller tanks in the top, and then we'll go back to the main tanks. They're about 85% full, and then booster, both fuel and LOX over 80%. So looking good there. The launch pad itself is getting ready for liftoff. We commanded the booster hold downs open already about 20 minutes ago or so. And then that just means that once that rocket has sufficient thrust to overcome its weight, your thrust to weight ratio goes over 1, it's going to lift off. We don't have a command to actually release the hold downs once it starts up. Just also a reminder, actual liftoff happens a few seconds after you see those engines ignite. So you'll see fire and then a few seconds before Starship really starts to take to the skies. Our range team just going to keep on making sure land, sea, air are all clear as we really count down. But that's the latest. We're just coming up on 10 minutes before launch. Everything looking good for Starship's 3rd test flight. I'll toss it back to you guys in Hawthorne.
Great, thanks, Dan. Now, if you've been following SpaceX over the years, you've no doubt heard us talk about our goal of full and rapid reusability. Nearly all of the Falcon boosters flown last year and this year have been reused, or as we like to say, flight proven.
We've landed Falcon 9 and Falcon Heavy boosters 283 times since first doing so in 2015. And with Starship, our mission is to take reusability even further by reflying both stages with little downtime between flights. And we plan to fly as often as possible. As we mentioned earlier, rapid and complete reusability is critical to enabling routine spaceflight. The team at Starbase has been hard at work developing and manufacturing the hardware that will ultimately take humans back and forth to the moon and Mars.
Now, even though we are not recovering Starship today, test flights like these provide the critical data that we need through every phase of flight. And that data informs future missions and gets us to that future where Starships are being recovered and rapidly reflown.
Our teams are also working on the ground systems that will support rapid reusability. When we start recovering Starship boosters, we'll want them to return to the launch site for a quicker turnaround, as you can see here depicted in this animation on your screen. This is when the tower reveals its dual purpose. After launch, the arms or the chopsticks on the tower will help guide the booster into position to ensure a soft landing. Now, if you're thinking that this sounds hard or even impossible to do, well, that's the inspiration for naming them chopsticks. Some of you might recall a little film called The Karate Kid, where Mr. Miyagi famously taught the main character, Daniel, that if he could catch a fly with chopsticks, he could accomplish anything.
Now, today we do have 4 ships and 4 Super Heavy boosters built, with more coming off the production line as our Star Factory continues to grow. These vehicles are slated for future flight tests just like today's, and in fact, just this week we static fired our next ship that's planning to fly and expect to test the booster as soon as the launch mount is free from today's flight test.
Now, as a reminder, today is still just a test. While we really hope to get our splashdown location in the Indian Ocean, but any data received will help us improve. It's the third of many future flight tests for Starship before it becomes fully operational.
And that's the goal of flight tests. They teach us about the limits of our design and improve our understanding of the vehicle, and ultimately help us make Starship more reliable and rapidly reusable. So whatever the outcome and however far we get, we can promise excitement. And things look like they are moving fast at Starbase, and that's exactly how we like it.
Yeah,
Rapid
exactly.
Iteration is a key of SpaceX.
Yeah, we've done it with all of our major innovative advancements, including Falcon, Dragon, and Starlink. We believe that if you're not failing, you're not learning and improving the design.
Yeah, many of the innovations that we've developed have come from our failures, and they teach us how to avoid the perils of spaceflight. It's a tough business. But all of this testing, all of the iterative design allows us to make the design better and better to do some of the great accomplishments with reflight that we've had so far.
Exactly. One of the examples that we love to talk about is the Dragon capsule, like the one located behind Shiva and I here on the mezzanine. Originally, it was not designed to be reusable. We wanted to prove the initial design. And then when we brought Dragon 2 online, we had to do a lot of corrosion analysis based on flights that had splashed down and analysis on hardware received there. And now our Dragons are reusable and also rapidly, at a much rapid pace than they used to be.
Yeah. So, I mean, great learnings from our original Dragon to our new crew and cargo vehicles have directly improved the operations, and they've helped us change our understanding of what's possible when it comes to rocket and spacecraft reusability. Now, we're just under T-minus 6 minutes, so I think it's another good time to check in with Dan for the rest of Terminal Count. How are we looking, Dan?
His accent's doing my head in. Very Californian, isn't it? Rapid reusability. Sounds like bloody Drew Barrymore. Anyway, back to Dan.
Just a reminder, ship, we're going to close out at around 3 minutes and 30 seconds, booster at about 2 minutes and 50 seconds. Once all of that prop is loaded on board, we'll have about 10 million pounds of propellant on both stages of Starship. Now, after that happens, we'll go through a couple of different procedures with the ground. We'll do what's called pushbacks, clearing out the lines between our prop farm and the vehicles themselves before we get to launch. And then in the next few minutes, we'll get the final guidance system alignments, some final thrust vector control on the booster checks, and all that will be performed. And again, if we need to hold, we have a hold gate built in at T-minus 40 seconds where we can hang out. It sounds like today we'll have about 15 minutes to hold at T-minus 40 if we need to.
By the way, we've got the SpaceX stream there and the NASA spaceflight stream there. But if you notice, I don't know if you can see the clock. There's a bigger delay on the SpaceX stream than on the NASA spaceflight. So expect to see, if it does launch, expect to see it launch from this telly here first. A few seconds, a good, 6, 7, 8 seconds before you see it there. So I just thought I'd warn you of that. Right.
Now, Dan mentioned a good point about the holds. We have an opportunity to today hold for a few minutes. And this is a really cool thing about Starship. And we don't have this opportunity with Falcon or Falcon Heavy. Up until the T-minus 40 second point, aborts are just holds. So anything that would trigger an abort prior to T-minus 40 seconds becomes a hold. So that's a really cool feature to allow the team to wait for final checkouts or assess prop levels, engines, avionics, vehicle pressurization. It's really helpful to ensure a liftoff.
Yeah, and that's something that is very different from Falcon. I'm sure people have watched our launches, and then we get right down past prop load and then have to scrub because of weather or scrub because of an issue on the vehicle. And we don't have the same constraints on our propellant and our system with Starship, which gives us more availability in the window. And sometimes that's all you need. Sometimes the winds dip just enough where you can launch the rocket safely. And otherwise, if you didn't have that ability to hold a few minutes, you might miss that window and then have to recycle to another day.
Yeah, exactly, which is kind of like today. Like we mentioned earlier, winds are the thing that we are watching. So good news there. So we are still continuing to progress. We're looking at liftoff in just under almost 2.5 minutes from now. Super exciting. Like we said before, there's nothing more exciting than watching a test flight for a developmental program, and that's where we're at today.
And like we talked about, we have some really ambitious goals for today's test. But really, the point of today's test is to try to get as much data as we can so we can inform the next iteration of the design of Starship, work those things into flight test number 4 and new objectives there that'll eventually get us to that glorious, rapid, reusable future that we so badly want.
Yeah, for flight 1, we wanted to clear the pad, and we did. For flight 2, we wanted to get through hot staging separation, and we did. So today, we want to get even further than that and collect as much data as we possibly can. So with all that being said, we're going to check back in with Dan to take us through the final 2 minutes of terminal count.
All right, we are under 2 minutes away. We have closed out the prop load on the booster and on the ship. And we're starting to hear some good news that it looks like winds are not going to hold us up. So there's a good chance we blow right through that 40-second hold. So we're about 1 minute and 20 seconds away. Just walking you through one last time, we're going to see the engines ignite about 4 seconds before we hit our T0. They're going to ignite in 3 different banks. You'll get 13 of the inners, 15 of the outers, and then the last 5 ignite just 2 minutes before T0. And then after that, the quick disconnect will retract. The engines will start to throttle up, and then we'll see liftoff about 1.5 seconds after T0. So we're under 1 minute away. Don't be shocked if we hold at 40 seconds before, but it sounds like the winds are cooperating today. And we'll be able to move right past that, not tracking any other technical issues that could hold us.
Proceeding past our QD vent gate.
Through the QD vent gate past the 40-second hold.
Go for launch.
Flight Director Ty Huntington telling the team we are go for launch. So 20 seconds to go. Let's listen in.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hold on, it's going. Hold it down. You can hear my stupid voice. I get all excited. All 33 engines are lit. Look, you can see them. I'll show you here in a minute. So this one's in front. Cool. All 33 Raptor engines have lit. It's off the
30
pad.
seconds into flight, we are feeling the rumble. We are seeing 33 out of 33 Raptor engines ignited on the Super Heavy booster.
Wow.
Avionics, power, and telemetry nominal.
Look, it's going through them clouds. Look, wow, that looks cool, doesn't it?
Continuing to get good call outs. Our trajectory looking nominal, systems looking nominal. Just amazing to see all 33 lit up once again. At this point, we've already passed through max Q, that maximum dynamic pressure, and passing supersonic, so we're now moving faster than the speed of sound, getting those onboard views from the ship cameras. Now the next major milestone is going to be a hot staging maneuver. Again, we're going to be doing that in just about 90 seconds. To do that, we're going to shut down all but the 3 center Raptor engines on Super Heavy. That'll be our MECO, our most engines cut off. And then the clamps holding the 2 stages together are going to release. Starship's second stage will ignite its engines, the RVACs first, the sea levels right after that. The sea level engines will be splayed or just kind of pointed out at about a 15-degree angle. So if you look close and we get good tracking, you might be able to see those center right after. And so those 6 engines will push Starship off of the booster. All right, counting down now. We're going to be coming up right at around the 3-minute mark on that hot staging maneuver. Again, we'll see the booster engines start to shut down. You'll see all but 3 lights go out in the middle. And then we'll see the engines ignite on ship, pushing it away. And that will start carrying the ship into space. Booster will start to do its flip and then move into the boost back burn, setting it up for eventual splashdown in the Gulf of Mexico.
Stage separation. Boost back startup.
Hot staging confirmed. Boosters now making its way back, seeing 6 engines ignited on ship. Kate, we got a Starship on its way to space and a booster on the way back to the Gulf.
Oh man, I need a moment to pick my jaw up from the floor because these views are just stunning. These are live views from Starship. First stage is currently performing the
ship avionics, power and telemetry nominal.
Good there, news informing us that the second stage or the ship, everything looking good, nominal there. First stage is currently performing the boost back burn, expecting that to last about 1 minute. That boost back burn, propels the booster back towards the coast, taking it to a landing in the waters of the Gulf of Mexico. We're only using the Super Heavy booster's 13 center engines from here on out. As whenever they relight, you'll be able to see that in the left bottom corner. Those are the ones that can gimbal. In other words, they move and change direction in order to change the thrust to steer the first stage back to Earth. Wow, these are just incredible views coming to us. Everything is looking good for both the first stage on the left-hand side of your screen or the Super Heavy booster, as well as on the right-hand side of your screen, that is Starship, or we also refer to that as the ship. Now, the boost back burn was the first of 2 burns required to return it to Earth. The next one will be the landing burn, where all 13 center engines will initially ignite and then transition into a 3-engine burn to help slow it down. Now, just as a reminder of the stage 1 test objectives, we're looking for controlled ascent, which we have so far. Stage separation, which gorgeous, we cruised right through it, as well as
on a nominal trajectory.
Good news there, telling us that the path that Starship is on is good. Now, Starship's second stage is still firing its engines, and as you heard, following planned flight path. The ship objectives, we're looking for hot staging, again, cruised right through that. We're looking to demonstrate controlled ascent as well as orbital insertion. Now, the bottom right-hand corner of the screen shows the ship engine graphics, so be sure to keep an eye on those.
Yeah, Kate, like this is just a phenomenal test so far. Super Heavy is performing beautifully today. It's on its return leg of the journey. Ship continuing to burn its 6 engines, those larger circles, the Raptor vacuum engines, the inner circles, the Raptor sea level engines. We're about 30 seconds away, just under 30 seconds away from the start of the boost back burn. The landing burn on the booster. You can see the grid fins rotating. Those hypersonic grid fins are guiding us through the atmosphere back towards our splashdown site. Again, we're going for a splashdown, a soft splashdown. So for landing burn, we're going to expect to see the 13 center engines light, rapidly bring down the booster's velocity, and then just the 3 in the center for splashdown. Let's see if that'll work. We're getting a few engines. And acquisition of signal. Let's see if we can get some other video of that. Now, this is a test objective today. It is still something that we're attempting to learn. And to make it that far, to demonstrate the controlled re-entry up to that point is pretty darn good. Ship continuing to look nominal with its ascent burn. This burn lasting about 6 minutes total. And we're expecting that this burn will end just after T+8 minutes, about a minute from now. So far, though, I mean, congrats to the team. Making it this far is farther than we've gone
Absolutely.
On Flight 2. Just wonderful views and great engine performance from the vehicles. So far, we've hit controlled ascent. We're in the middle of that right now. We demonstrated the hot staging. Kate, as you said, cruised through that. We demonstrated controlled entry of the booster. Just stopped a little short of the engine relay, but hey, that's something we can learn for the next one.
Yeah. Now that view that we just had moments ago was a live shot of Star Command. There you see it again. This is our mission control center at Starbase. Where vehicle operators are standing by. Now, the next milestone coming up is in less than a minute. At that point, ship will, or I'm sorry, actually, it already has.
Starship engine cut off.
There we go. As you heard there, by the call out and from the crowd behind us.
Starship orbital insertion.
Starship's 6 Raptor engines have successfully shut down. We heard a call out for nominal orbital insertion, which is incredible. Look at these views, Dan.
I'm just completely blown away right now. What a day. Congratulations to the entire SpaceX team. I mean, this flight pretty much just started, but we're farther than we've ever been before. We've got a Starship not just in space, but on its coast phase into space. Just to recap where we've come, and it's only been 9.5 minutes. How has it only been 9.5 minutes? We lifted off right on time at 8:25 a.m. We didn't have to hold at our gate at all. We had 33 out of 33 Raptor engines open up and light and get us through a nominal ascent. Another successful hot stage. All 6 engines on the ship propelling us into orbit. We did see what looked like a nominal boost back burn. And then we did make it all the way to the landing burn this time. Didn't light all the engines that we expected, and we did lose the booster. We'll have to go through the data to figure out exactly what happened, obviously. So be on the lookout for information about that. But wow, a ship in space. We've got a bunch of, as we said, ambitious objectives ahead of us over the next couple of minutes and pretty much over the next hour, where we're going to really, we've got the ship in space. We're now going to take advantage of this and try and learn as much as possible about some of the other systems, including that first ever Raptor relight in space. So it's just going to be incredible. So all of that still to come. The mission just started, but wow, what a liftoff! What a hot stage! What an amazing sight to see Starship there in outer space.
I can't believe we're seeing it in space. This is awesome.
Wonderful.
Now, we are going to be coasting for the next about 30 minutes or so. We'll be back around the T plus 40-minute mark, and that'll be Starship continuing to coast.
They've got to wait now and see what happens if they can relight the engine.
To re-entry. We're not
And
totally sure what video that
nose dive it into the Indian Ocean or whatever they're going to do.
As we overfly ground stations, and
I'll keep going though. I'll not get out of it. It'll be boring. Just going to see it just in space. Maybe we'll see a UFO. Fingers crossed. I don't know if you can hear them. It might be echoing. I don't know. But let me check.
It's a possibility, but either way, we will be live for all of today's milestones. And of course, when we do have views,
Puerto Rico.
especially like the ones that we have now, which I just cannot get over. When we have views, we will be sure to bring those to you live. But no
there's
views
no echo,
or
not
no
that I can
views,
tell
we'll see
anyway.
you back here at T plus 40
Not that
minutes.
I can tell.
And there we just heard call it that Pez door is opening, so that's great.
First test.
We
One of
saw
our
a
test objectives
Starfleet
today is
ship
to
on
open
the
and close
ISS
that Pez door.
feed a
That's
few
where we
days
will
ago. I
deploy
didn't see that.
Starlink satellites from
A
in the future.
Starfleet
So
ship,
great
which
news
one
there
was
that
it
that
then?
test
Looked
excuse
like
me,
Voyager to me.
that test
I
objective
didn't see
is
that.
already
I didn't
underway.
see that.
So come back here, stick around
You'll
till
have to
T plus 40 minutes for coverage
find,
of Starship's deorbit burn demonstration.
Tell us where it
followed
is,
by
if it's on
re-entry
YouTube or whatever, I
and
don't
what
know.
is sure to be an exciting splashdown.
Give us a link or just tell us where it can be found. We've got music now. We've got Muzak playing, elevator music. Don't think so. Let's go and hang on. Let me just get rid of this a minute. We'll go see what the chaps at NASA Spaceflight are saying.
That help with landing burn, because if you imagine the landing burn of the ship, the ship goes a horizontal configuration and makes this very violent flip, basically to go into a vertical position and then land, hopefully. Not this one, but down the line. And these header tanks are basically there to.
Hang on, we're not
they are
live.
easier to. It's
That's it.
looking unless something
We want live, then.
majorly goes wrong with this in space burn now, we will have a good chance of seeing the re-entry here.
One way or the other. And they kind of teased it on the SpaceX side that we may actually see something. So I would imagine there's probably, I saw a super chatter earlier mention that they were tracking some flights in the area in which it's expected to come down. So Alex, do you think we might see the
we
rapid
don't take
schedule
out a jet
disassembly
on its way
if,
down.
re-entry is a success?
Well,
That'd be
I'm
spectacular,
mostly
wouldn't
sure
it? If they
that
had
they're gonna have onboard, perhaps
should have
more
some
views.
planes
This time
in the
around, they're
area
working
to,
way much
you know,
better.
film
You
it.
see those upgraded Starlink antennas. by
External
the,
views.
Quite a beautiful upgrade that they have installed on these vehicles. Boy, I'm still processing everything, right? And the fact that we are in that coast phase right now, Starship is in that phase, and boy,
I have to
Go. You have words.
mention something here. Yeah, we have something for you because we like to celebrate milestones like this, right?
We sure do.
I'm so happy we can release
Just
this
checking
design
the
because I love it.
not a-
There's our
not an
now
echo.
available re-entry
Look,
club.
they're flogging the
at
merchandise now.
shop.spaceflight.com,
Look, re-entry
and
club
I think this is one
merchandise.
of the best designs we ever had. Like, if you want to celebrate, this design is now available on shop.nasaspaceflight.com. So I hope you enjoy this. I think Pauline outdid herself
Get
with
merch
this design.
drop.
It's fantastic.
It
We'll have to
looks
get some of my
awesome.
own
And, you know, we
merch.
cover high velocity
where to
rockets
do it,
on
though.
this
I
channel.
don't
We
know
have
where
high
to get the,
velocity merchandise. So as soon
do
as,
my own designs.
as
I
soon as
was
something
trying to.
happens, we're ready
Is it
with it. So
spreadshirt
awesome stuff. We've been
or
holding on
another?
to
I
that
can't
for a
remember
while,
now. I've got
and
it.
we
I've got it in
will
my
be re-entering
favourites.
one way or
Okay,
the other in
see
just
my
about
favourites.
20 minutes or so. So
And,
right
and
now,
it
SpaceX
rejected
is,
my logo
reporting that the
for some
cargo bay
reason,
door
and it wouldn't let
opened
me do anything.
successfully. That's going to be important for their
So,
future
anyway.
Starlink missions and other customers that may want to use
By the way, I've
Starship as their launch
resubmitted
platform.
my
It can haul a lot of weight up to orbit, and that's going to be important for commercial
monetization
viability.
request thing
We
application,
don't yet, I
and
believe,
it's in
have
progress,
any
so we'll
indication
see
as
what
to
happens.
whether or not the
on my
fuel
YouTube
transfer
channel.
test has occurred. So we will await that. And then the big test, Alex, is the entry. And what we're hoping for here is a re-entry to the atmosphere. No special flip maneuvers or anything. We're going to hit the ocean hard here, aren't we?
Exactly. So as you were mentioning before, we're definitely in that sort of trajectory where one way or another we are re-entering over the Indian Ocean with Starship.
Still
I
in
believe they are
progress.
currently in that
Got to sign
first
up for
phase,
AdSense for YouTube, and it kept telling me I had
particular on the
I'm only allowed
portion of the
one
flight where they should be approaching the moment of the cryo transfer milestone.
account, one
It's gonna be an
AdSense account,
important
and apparently I've got
milestone.
more than
So
one. I
hopefully
don't
we
know.
get
I don't
any
understand it, so I've
news.
reapplied.
There
See
we
what
go.
happens.
We have some views there.
Anyway,
Is that the payload?
I bet
Bay door
Windgrace has
opening?
got merch.
Ooh, look at that.
Bet
Look,
he
is
has.
that? Look at that bottom there. What is that?
Is that a
I
fuel tank?
believe it's probably condensation from the inside, because they have these.
We're looking
these
inside
lines to the
Starship.
The head tanks are on
Cool.
the nose cone. So this is from the inside of the nose cone. And obviously that was probably some leftover, but you can see some
Bits flying about, floating about.
Floating pieces there. There are definitely microgravity there. Oh my gosh. Slowly opening.
Insane. This is like, okay, can we already like?
Ground
I'm
control
already
to
above
Major
expectations.
Toy G.
Oh yeah.
I'm far above. Completely. I was like, hopefully they get similar to Flight 2. That would be cool. No, they just smashed it. They just smashed it.
I mean, it's probably too early to to recap everything, but we saw a successful ascent.
You got excited then, didn't you? Successful.
Hot staging, ship engine start, boost back burn start on the booster. The booster went through re-entry. And
So this is in the nose code. So this will be in the future where the crew will be sitting, won't it? They'll be putting stuff in there for the crew at some point. This is in the nose code.
Burn. That is something that they obviously have to work through.
Oh, but
that was the new thing.
Oh, hang on,
right?
there we go.
That was, a new thing to do.
Well, we're seeing the yes, we're seeing
the
door open.
You know,
cargo
they'll learn
door.
from it and do better next time. But there you can see the payload bay door is slowly
Probably payload
opening,
bay cargo.
and we're getting another milestone ticked off. The ship
Shuttle
is on
bay
that
door.
trajectory to the Indian Ocean. the payload bay door is
Don't
opening.
lose the signal now, bloody hell!
It is the moment that they're gonna be doing that transfer of propellant from headers to the mains. I mean, that's a short recap, but it is nonetheless any little thing. It's quite an amazing step forward compared to Flight 2, and I guess we have cameras back.
And we are not done yet. That's the we are already talking about. We are already talking about what an amazing step this is, and we are not done.
Right, there's more. But on the last flight, we saw the amazing, the launch and hot staging, and then 2 RUDs, and that was it. So we have more to talk about here, more coming down from Starship, and you can see us now too. It's been an exciting morning. It's been actually fun watching the two of you on camera here.
This is Alex,
as
I
this
think.
is
I could
going
be
up.
wrong.
And one of the things that I love about
Starship
working with you all
Christmas
is just
jumper.
the excitement that we all share for this. And as you're watching, guys,
look at that.
Alex, it looked like it was, almost not a routine launch, but it almost looked kind of normal here, that everything just worked.
Yeah, I mean, boy, it's like the ascent portion worked just as expected. I'm mesmerized.
Bits flying off. Wow.
That's why I'm not looking directly at the camera.
Ice particles.
Not
alien spaceships.
Our feed. And boy, it is such an amazing view that we have. This is something, ever since Flight 1, I was like, please.
Are you going to faint? The blood pressure looks a bit high. Hang on, I'll get rid of me.
Coasting at orbital velocity.
Get rid of that.
It is such an amazing thing that we
pass
finally
out?
are
Is
seeing
it that,
this.
that excitement? We'll have some sort of
long
aneurysm.
list of milestones. I'm almost losing my voice because I was muted when the liftoff happened, but I'm mostly sure that you, Lon, were seeing me yell out of my lungs basically here. I was
I
yelling myself, 73 Raptor engines again! Things like
that was the reason why I also was muted, Alex. Like I
Yeah, everyone
knew
was
I
muted.
had to click this mute button because there was no control. There was
Can you hear them?
absolutely
Okay,
the control that
my
SpaceX
phone,
demonstrated
see
with
if
this
you can hear
vehicle.
them
Alex
okay.
and
So
I
lowered the
had
volume
that
right
problem.
down.
Not at all.
I could hear
Yeah.
you through your mute button, believe it or not. So it was definitely exciting here.
It
Let
was
me ask
either
you
our
this.
yelling or the engine, sounds. I think the engine sounds are more
Oh, yes, you can
cool.
hear them. You can hear them.
Right.
You can hear me as well,
And it's
stupid
still
voice.
amazing to watch something that large take off. And we talked about the height earlier, but the diameter. We saw some interior shots
The
earlier.
most powerful
Almost 30
rocket
feet
ever
in diameter.
has
So it's
successfully
So-
launched. Finally, on the third
It's
go.
enormous.
it is
and
enormous.
I love that
So
we're
we
seeing
are-
it rotate here because that means they're using those vents.
I mean, it successfully launched on the second go. It just, something went
Also, I'm
wrong.
seeing. I'm
It
seeing
went
new things. I'll
awry
probably
before
talk
it
about
got
this
into orbit,
afterwards,
didn't
'cause
it?
obviously-
Or
Yeah,
orbital
so I already
space.
can tell you this.
Yeah.
So this week's Starbase update.
As I said,
Two
technically
things
it's
I
not
can
going into
confirm.
orbit
A,
now.
It's going to be long,
Near
and
enough.
B, it's going to be written by at least
But
3
it's,
people. Because I know
coming
Alex
down in
has
the
something
Indian
to say
Ocean,
about
it's
this,
a
I know Ryan has
suborbital
something to
flight.
say about this, and I have something to say about this. So it's going to be
Just-
like we did this one time where we just sat together in a VC and just wrote one script, and I can tell you this week's Starbase update. That's going to be
gonna be
another
the
one of
same.
these.
Just look at how the ship rolls. You got to think about.
How can they lose the signal? He's got all those Starlink satellites. Surely you'd think he'd have some of them helping
We saw the booster maneuvering
with the signal.
without the engines running. What that means is that it's using its own vents as the thrusters. This is probably the first time that I see a vehicle, a rocket, using its own vents to maneuver through space and through microgravity environment. It's quite crazy, and we see the same now with the ship. The ship is maneuvering. It's like rolling on its side, probably preparing for whatever up next. I believe the next thing is the cryo transfer. Hopefully, we get some updates from SpaceX. But boy, that is crazy, right? It's like a new way of maneuvering in space and things like that. You don't need pesky extra thrusters or anything like it. Just release.
Let's
some,
have a look, see if I
some
can
of your,
find this Starfleet
pressure
ship
your
on the
tanks and
ISS. What
whatever.
ISS feed?
All of those things
Was it
are part of the
outside
things
the
that they are
ISS
demonstrating,
or was it
right?
inside?
Right now, obviously, they have.
Did an astronaut have a model of a
lots
starship?
signal.
Is that what
They
you're trying to
tend
say? I
to
don't
have
know.
those as they probably
didn't
switch
see it
between
anyway.
Starlink satellites, or the ship just goes in a bad orientation for that.
I'll
But they
I'll
also have
Google it
ground
and see if it
stations,
finds
so we'll
anything.
probably get those views as well once they get into ground station views as well. It's just mind blowing. I should say. Sometimes I feel like like my scene is not show so much excitement, but sometimes it's like I can be very annoying when I'm very excited. So I don't want to feel annoying for the viewers out there. But
Yeah, we are.
Boy.
It's always hard to find the right balance because hey, you want to be very factual and like, but then I mean, how can you just be factual if you see this?
Right.
Yeah.
It's well, there is something about I remember watching the space shuttle launch take off, and I was talking to a seasoned journalist there, and he
I
had seen
don't
a million
know.
of these things. And
Yeah, there's
even after
Starhopper.
This one, he
It's
went
called
off. The latest one
Starhopper,
that I
didn't
saw
it?
with him, he's like, it's almost like it's not even created by humans. It's just amazing, like the amount of force and power and light and sound that come off of these things. Basically, a controlled explosion all the way up is remarkable. And now we've got pretty much a spacecraft operating now as a result of this launch. The only thing I wanted to point out while we're waiting for some news on the next stage of this flight, we expect another milestone, in about 15 minutes, I think, for
I
re-entry.
wonder when we'll get.
But
Technically,
we did
this is a
see that
two-stage
booster,
rocket, isn't it?
maneuver quite well.
So I
up
wonder when
until
we'll
it
get
got into the
single
thicker part of
stage
the
to orbit
atmosphere, and it looked like
rockets.
it was probably the flight terminated at that point.
I wonder when
What
we'll
did you guys
get
see
them.
there?
Because I always
Yeah, I
remember
think-
at the
so I
first,
think what I saw
at
is
the
that
launch
only
of the
one
first
Raptor
space
turned on.
shuttle in
Like,
1981.
like,
Yes, I'm
I
that
have to-
old. I remember
I need
watching
to be
it.
placed off this. This is
More-
this
They had a
more than one,
scientist
but
on the
yeah.
BBC.
It looked to me like
They were talking
at
about,
least
you know,
they
what's going
didn't
to come in the
reach
future,
enough. I
and
also saw the color
the
green.
scientist said,
I have to say, I for sure saw the color green, and that's never
in the
a good
future,
sign
and he says
if
not
you
in
see
the
a
near
Raptor start up
future,
with the color
we'll
green involved.
see
That
single
usually means you have
stage
some
to
engine
orbit,
rich, that's
vehicles.
usually
The
engine
fuel
rich
mixture's not-
combustion.
How
what we're
long
gonna see.
it is before we'll get
And we
that.
saw that on some of the test flights. Now, by the way, we're looking right now from
So,
our cameras
it-
at the launch complex. What does that look like to you, Alex?
It appears that
it's
they
a-
have started the demo.
Even the
for
Phoenix was a
cryogenic
two-stage
transfer,
rocket,
I
wasn't
believe.
it?
I think I heard that on the call-outs.
In Star Trek First Contact.
Okay, so
But
we're
yeah,
trying- so-
Hang
Go-
on,
go
where
ahead.
it is. It's saying,
I was going to say, so the
can't find
cryogenic
the picture
transfer, before we
online
go
now,
to the
so
launch
probably,
pad there, so that's a big test for
oh,
NASA to
so
demonstrate
real,
that
they
they can move
scrubbed
fuel in
it,
orbit on the
right.
system, right?
Yeah, and I actually, spoiler alert, I spoke with people at NASA about this sort of how hard and how challenging this is. If you think about it, this is in
So
the
I'm guessing it
microgravity
were
environment.
outside the space
You have
station.
valves that need to open, pressure gradients, and
guessing.
all that stuff.
then.
Essentially, what you
42,
do in the
past
ground,
week. Yeah, so,
we know how
yeah, it's
to do
not
that on
there,
the ground.
can't see
There's
it.
gravity, right? But
Gravity.
when you remove the gravity component, it's sort of the same thing as trying to orient yourself. When you remove that, we don't know how to orient ourselves until we actually learn about that. And how do you learn about how
it
to
might have been
transfer
Voyager
cryogenic
coming back.
propellants in space? Well, that is
like it did in the
this test
episode.
that they are doing right now.
I forgot the
It
called it
is small compared to what we need
now.
to
That one where they
transfer
came back
in
to
the future.
1980s. LA
But you can scale it up.
could have been
Hang
been
on,
that.
I
They
just heard.
They moved
It
everything
looks like they
forward,
have
haven't they? Because of
completed the
Strange New
test. It was
Worlds.
quite
Or
quick,
moved everything,
to be
whatever.
fair.
Moved everything back.
Wow.
I want to
whatever.
point out, I'm not sure, and I'm not sure if that makes other people nervous here, but I'm not sure if so far
What episode called now? That
they have triggered a
two-parter. We had
mishap
Begley
investigation.
Jr.
The booster's a bit iffy.
And,
we will see if that triggers a mishap.
comedian.
But if the mishap they have triggered
Future's
so
End,
far,
that's it. Future's
might
End.
be small.
Thank you, Winggrace.
So I think we have a good chance that so far they have not significantly triggered a mishap. Go ahead, Alex.
So the propellant transfer demo is complete, which is quite amazing. That means that is good news. And they should be preparing to close out that payload bay door. You can see there that feed from inside the nose cone, the payload bay. Hang on, I need to point my. Oh well, now it's gone. Whatever. But yeah, one of the complicated things about this is not just the transfer; it is also keeping it cold for long terms. And just to put this into perspective, this sort of thing of transferring cryogenics between vehicles in space, it has been tried before, but with quantities in like the single digit of kilograms. We're talking here single digit of tons. It is 3 orders of magnitude. It's 1,000 times more propellant being transferred here, cryogenic propellant, than what has been tried on previous missions. So this is quite a step forward. And in the future, instead of being single digits or 10 tons of propellant, it needs to be 1,200 tons, which is what the propellant load is on the ship. And in future versions of the ship, it'll probably be even more. So that's a lot of more propellant that they need to transfer in the future. But if this is indeed a successful test, then we're
Yep, it's the first step.
off all the boxes. It's kind of crazy.
And it is kind of crazy because, and you think about it, just having it still be
What's happening here now? Is this a
intact
replay? Are
spacecraft
they
at
opening
this
them
point,
again? Or are they
is
closing
far
them?
beyond where they
Okay.
were before, but they're also now meeting the milestones. The cargo bay door, we're waiting for confirmation on whether or not that has been closed properly. The fuel transfer looks like it is complete, and now the next step,
the
of
door is
course,
closing.
is
What if it's got an alarm going like on Next
Getting the
Generation?
updates here from
Yep.
SpaceX.
I love the music they've chosen. We didn't get the usual space tunes.
That's what you've got to have, innit? When you're doing the
And
shuttle
yeah,
bay
I
door.
think we are approaching now so there's one final
force
thing that
field
could go wrong here, right?
activated.
That's the in-space relight of a
Relight.
Raptor. If
Right.
that goes well in 12 minutes, I mean, then we are going for re-entry. Like, if they don't close
It doesn't
the ship
close
now
properly.
with
Little
this,
astronaut will float down.
with this
Little
in-space
expendable
relight,
astronaut that
I'm
they didn't
feeling
care
quite
about.
optimistic about it.
Probably they bought
Then
somebody.
they're going for
They'll go
re-entry.
down and just kick it into place.
Every single Starship flight, I don't know if you guys feel the same, but it feels like what is going to be the milestone where they,
Because
have
Elon
a-
Musk can
have a
buy
run?
people now. He's that rich,
I
he can just
expected
buy
the booster,
people.
So the booster outcome is pretty much what I expected, that it will ace the boost back burn. It will probably go through re-entry more or less unscathed, but perhaps towards the end of that entry, not the entry burn, excuse me, the re-entry, just that.
Watch all the
it will-
barrels
it
get
will go through the
blown
re-entry,
out the
unscathed,
cargo
and
bay
then
door. Yes. Geordie
towards
and
the end, it will
Beverly
probably
hanging on.
have an issue. It's what we saw, and I just heard a call out that Raptor engine chill
And I'm
has
glad you said
started, so
blown
that
out
is
and
good,
not sucked out.
because that means they're
Get
preparing
your
for that
terminology
relight
right.
of
Yes,
the
you
Raptor
did.
engine. Remember, it takes about 19 minutes or so to relight. To chill down the engine. So we are at T plus 30 minutes, so it kind of makes sense because I think it is we're 40 minutes or so into the flight. So we are on that path to that. So yeah, it's like, when will this thing fail, right? When will ship 28 fail? So
Oh,
far it's ticking down all
steady.
the boxes, and frankly, it may go all the way to the ocean. Who knows? We'll figure that out.
That's what we're waiting for. Here's another great view from Starship right now.
Because if they don't close that,
minute mark, and
I mean, I know it's
a
on the
spaceship.
opposite
And we're
side to
seeing,
where
so they're using these
heat shield
venting,
tiles
these venting,
are.
well, this looks like the
But
engine venting for relay.
would
right?
that cause
That's
a
what we're waiting
problem on
here.
re-entry?
Yeah.
Yeah, this is.
I mean, it might knock it.
So
I don't
but
know.
they-
He's
we are
going
seeing
kind of
there might be
orbital
multiple
speed, isn't
things
it?
we are
So
seeing. Sometimes they will also start to vent some gaseous
see.
boil
We'll
off
see what
at these
happens.
points, like other rockets do. But part of this will also be the engine chill that is ongoing right now, because the engine chill basically means you flow some liquid oxygen through your engine and prepare it to be not cryo shocked. So that's what they're
looking
probably doing.
closely, it's because I'm looking at the. Ooh, look at that! All the frosty bits and coming
yeah.
out. We see a similar thing on the MVAC engine on Falcon 9, if you remember.
Right.
When they chill down that engine, they have like this chunk of
Right, of ice
I
that-
can't tell if any
of
tiles
ice,
have come
yeah.
off. There's a white
So
mark.
that
Where's
is
my
very
pointer?
interesting. You can
Where's
see.
my mouse
I'm also
gone? Where's it?
focusing on the
Can
tiles.
you see it?
Um,
There's like a white area. Is that a tile that's
there
damaged?
might be maybe one missing. It's super complicated to say, and that is a good
Aiden's
news.
shouting at somebody.
Good
No, it's
news,
the
excuse
cat.
me. That is good
Shouting
news
at the
because
cat, she just
with
come
ship
running down.
25, it was very easy to notice
Is he
that
getting angry with you,
tiles were missing.
princess?
Right.
Now it's like
Manage, hang on.
maybe here
one or
and there, like
two, right.
looking at the footage, it's like maybe one, right? It's that kind of thing where, okay, maybe if it's like a couple of them, might still be good to go. That's what we're gonna figure that out, right? In just a few more minutes. Boy,
It's amazing to see,
Yeah,
this
good to
iterative
see that.
approach. It's really neat to see this iterative approach really paying off. And Adrian, what I'm watching here is something that I once heard about in the space
Just let
shuttle
the
program,
cat
which
out.
is called barbecuing. Is this being done for thermal
and we
purposes
achieved
to try to
all
keep
this with
the
rocks we dug
temperature,
out of the ground.
equal across
Essentially,
the two
yeah.
sides of the spacecraft here, or is this
Essentially,
just to demonstrate maneuverability?
I'm wondering about that. Do we know if
With,
Starship is barbecuing, Alex?
Elements
Is
Kinda
there
looks like it.
created in the hearts of stars.
It kind of looks like it.
I'm celebrating
they
with
seem
a
to be
chunky Kit
doing that
Kat.
barbecue roll. One thing that I'm
Other
interested to
chocolate
see
bars are
is sort
available.
of relight demo.
This is not a
Um,
sponsored
Is
live
well,
stream.
two things.
But I'm hungry.
Whether the ship goes back on it, so right now essentially moving in one direction, right, and then reorienting back, or if it will keep being thrusted, basically pointed forward. So far, from what the graphic on the SpaceX stream points out, it looks like it's pointing back. One of the two questions that I had, or rather a single question, but with two sort of potential answers, is whether
it said,
the ship
hang
will
on.
go into a
Pez door,
toroidal
checkout
trajectory,
complete, door
basically
closing,
where
and
it goes
HD views
short,
are over.
and then it burns forward,
Well, entirely.
right,
We're
for
not going to
that
see anything
relight in
more, are we?
space, or whether it goes long and then burns back with that relight in space, and then it comes, a little bit early in that long re-entry window that we showed earlier before the launch. That long re-entry window, it is a very important one because that's what allows them to do that. So it looks, at least for now, that the ship, if that
Well,
graphic
we're
is
getting
correct,
to the
is pointing
time.
back. So it will be.
It won't be far off now, will it, where they try
slowing
and
down,
reignite
and
the
therefore we
engine?
should see that speed
Or
coming
engines.
down.
I think those
And
maybe those
what
three middle
happens-
ones
What
that tries
happens
to
if
reignite.
it doesn't light? I would imagine gravity would eventually take over here because we're not quite in an.
Or will it
in
be
an
the
orbit.
outer ones? I don't
Yeah,
know.
it will re-enter over the Indian Ocean. It will be essentially in the same re-entry corridor, but I imagine that it will be further out, further basically downrange, so to speak, in that trajectory instead of being much earlier in that trajectory. With that burn, you're essentially slowing down, and therefore you're re-entering a bit earlier in that trajectory. but it's still that re-entry path, that those hazard zones were made essentially to take into account, what if it fails? Well, you at least have that sort of margin on that re-entry zone to be able to, account for a potential failure. I love all of those fins. It's always nice to see
It's so cool.
as a spaceship being active in space.
Right. It's neat to see something with aerodynamics active in space, right? That was one of the things I
That
loved
is
about
also
the shuttle.
true.
You
Shuttle fans.
didn't need those wings
Hi,
in orbit, but it
Chris.
was just cool. Yeah.
Was that a thruster?
That's what I grew up
like
on. It was
I
always
RCS? Is that,
awesome to see
or is that just
you reminded me of a
just
quote
light
from
reflecting
Elon
off
when
it?
he said, "Oh, wings are silly. Why would you carry them into space? We don't need a shuttle." And now that was a long time ago. That was probably a decade ago. And well, sometimes kind of need some aerosurfaces, some flaps in this case on Starship.
Right.
It's not that silly. They have a reason to be there, and so obviously not the giant delta wings of the shuttle, but some aerodynamic features are, needed to be able to re-enter through the atmosphere at the end of the day.
Stubby
there's
wings.
air.
Stubby wings. And what we are
Exactly.
seing here right now is normal. It is, as you can see, what we space people like to call barbecuing, where it's just kind of like a rotisserie, just kind of spinning around. We don't know if that is for maneuverability or for thermal balancing, but it is not out of control. That's what it's supposed to do.
So I'm guessing
And
that
what we're
door
waiting on
closed
next
properly then.
is the
Little fella came
relight
floating
of
down
the
and kicked it
Raptor
into,
engine, which will,
into
or a
place.
couple of them, which will slow it down so that it can re-enter the atmosphere. And the last stage of this test is to test those thermal tiles, because we haven't had a Starship yet get into orbit,
Sorry,
or close to orbit like this one
micromavity.
is, and re-enter the atmosphere in one piece. So the next stage here is to have it re-enter the atmosphere like it will in the future on its operational path, and slam into the ocean in this particular instance, but later they will try to catch it with the same launch tower that sends it off into space here. So we will keep an eye on that engine chill as it finishes.
So with this going successfully now, will it be quicker for them to get the next one out, ship 29? I don't know what booster we're on.
Should be
Booster
less than
12,
4
I don't know,
minutes
I can't
for that
remember.
relight. And go ahead, Adrian.
Get ship 29 out onto the pad. Will it be a lot quicker turnaround? Because there won't be a big investigation, will there, into why it blew
let me
up
ask you this, Adrian. This is the first time
by
we've tested
the FAA
Starship
and all
and
that.
these stubby wings in lower altitudes, right? So we
Will
know
it be a
how
matter
they'll
of weeks
perform
rather than
lower.
months
But
before
we've never had a Starship
flight
get
test
this
fall?
high and actually have to simulate the entire return trip. Obviously, we're not going to try to have a control, or it's going to be a controlled belly flop in this case, but this is a big milestone for its maneuverability post-launch back in the atmosphere.
Yeah, absolutely. I mean, all of this right now is new. All of this is just, it's so much new data. And imagine the amount of stuff that SpaceX learns from all of this. Like we already are excited. Imagine being an engineer right now, designing a Starship. Like you're probably having the day of your life. I want to give, by the way, a quick hint here. The fact that we will probably sell out of the Flight 3 patch
the water
in minutes
for
now.
USOs.
So if
yes.
you want to grab one,
Get your orders in.
now.
Objective today was to get through all of our ascent burns
Because
and collect
UFOs
as
are
much data as
UAPs,
possible,
so-
including a potential Starship entry.
They call
And, we
UFOs
just came out of a coast phase and we're
unidentified
treated to a number of HD views thanks
aquatic
to Starlink,
objects.
including the
UAPs,
PES door
isn't it?
open-close test. So that was one of our test
Too
objectives
confusing.
today that we met. So that's awesome. It has been such a great day.
It has been a phenomenal test day. Just to see booster lifting a Starship to ascent, ship completing its ascent.
Booster.
Just a wonderful day. Kind of to recap the objectives a
Sorry,
little
Wing
bit.
Grace. I'm
Booster
taking the mickey out of
completed
your
its
countrymen.
ascent, ignited its 33 Raptor engines. We demonstrated a successful hot staging for the second time. Booster completed the boost back burn, didn't quite accomplish the landing burn, and then had a hard splashdown in the Gulf. Meanwhile, ship completely successful after the hot staging. We had a good 6-engine burn of the Raptor vacuum engines and sea level engines. And then we've commanded a number of demonstrations, including the Starlink satellite deploy demo, so the payload door, as well as a prop transfer demonstration. We do still need to do some data review on those, so as we get that data back, we'll be sure to update you on social for how those tests went.
They live further from me than your
right,
entire
so it
country.
looks like
Yes, they do. Yes, they
A
do.
lot of good things happening here, and we're just waiting for that engine burn.
So I don't take offence.
Absolutely. It's, I mean, so
Boy.
far, this
Merch
is,
drop again.
This is just
And-
astonishing. Speaking of astonishing,
Our
we
high
have the
velocity
first
merch.
Yeah, Metal Prince, the first one. This
Metal
one next from Liftoff is up. Shop.nasaspace.com. So if you want to have this launch on your wall, there you go. And also, and I want to point this out, and it's probably the most important part of these metal prints, you support the photographers who take them. So every time they you buy a metal print from one of our photographers, they get a cut, and it
Josh
supports
Temple's
them.
here.
It supports
Good
them getting
morning,
new
Josh.
lenses,
We don't
and
need your
they've rented
harpoon.
expensive equipment
They
for
might
this
need it
launch,
when it
so
splashes down into the
this
sea
is really
to fight off the
a way to
sharks.
support them and kind of help them.
The
out
little
here.
fella that's floating about
They look
inside.
great on the wall, so I have to get
The
a few
little
more.
expendable
Get
man.
my office here loaded up. So just
Yeah,
in case
I'm
you're just
kidding.
tuning in, Starship launched successfully, the booster and the ship. We had a successful stage separation. We have a current Starship in essentially an orbit of some kind, where they were able to successfully test the fuel transfer. The payload bay door has been opened and I believe closed. And now we're
We
waiting
should
on
get
that.
on a relight demo, right?
Yeah, we're at
Yeah.
that point, right? So the
Now
next
we're going
step
to
is
try
to
and
relight
relight
the
the
engine, slow
Raptor
it down,
engines. I don't know which
test
ones,
out
the
that
middle ones or the
thermal
outer ones. I
system,
don't know.
and we're gonna
Presumably the
maybe see
vacuum one.
a
think,
splashdown
I don't know.
in the ocean for a rapid scheduled disassembly.
We are
So
basically waiting
on
for
that
them
right now.
to. Yeah, we are basically waiting for them to acquire signal again. And once they have acquired signal again, they will probably be able to confirm this, right, Alex? Like, this looks like they are.
Yeah, it
They'll-
also appears that the okay, it seems like they are skipping the burn. The
Oh.
computers essentially confirm whether the Raptor engines are good to go for the burn, and they had the option to not do the burn if anything looks bad. If you think about that, it makes total sense of not trying something that you know will break your ship. And as we were mentioning before, the reentry zone is completely wide enough to be able to allow this reentry in a safety zone. So without the relight, it is okay. They're gonna be coming back into a safe zone, and now I'm guessing that the ship will try to get into that entry attitude for the reentry.
I
So
wish
we'll
Discovery
see,
had skipped
we'll
the
see what
bird.
happens,
Yes,
and
so do
keep
I.
listening to them because yeah.
So Adrian, without this burn, I would assume then it's going to take a little longer for it to come back down.
Yes, basically they would have probably slowed themselves down, which would bring them up. I think there was early. I'm now getting my orbital mechanics mixed up, but they would have come down later. Yeah. So I'm just making sure that I'm not saying anything stupid about physics while Alex is here, because if I say anything stupid about physics while Alex is here, we will
Oh, look
call
at
me
that.
out on it. Oh.
Oh, wow. Well, looks like it is
We
coming
will
down
see
now.
a re-entry.
Yeah.
This
All
is
right, so
this is
this
gonna
is,
be
the-
insane, everybody.
This is going
It
to be
is
insane.
already
Now,
approaching
So they're going
the
to
entry
just. Is
interface.
it just
It's
going to topple into the
152
atmosphere? They're
kilometers.
going to try and, bring it in
So
and belly
let's
flop
see,
it
let's
in.
hope for
Don't know.
the
what
communications to hold.
right.
Look at that.
Now it's still doing a little bit of
How it's
rotation there. They're going to try
maneuvering
to.
and everything.
Yeah. So you think this is more maneuvering than a continued rotation?
I mean, they need to cancel this rotation at some point. Like, the problem is for the re-entry, it at some point needs to get stable. You need to get
also
Right.
flaps first.
Yeah, I'm looking carefully at that graphic of the attitude.
They need to get it tile
Yeah,
side
that
down,
could also
don't
be
they?
a point of failure, right? We gotta accept that we're already way past of the progress that we did that we saw on flight 2. So if this point of the ship cannot control itself and put into its correct orientation. Hey, well, ship 29 will try it, right? And more future vehicles will try it. It's progress already. I cannot emphasize that this is progress.
Oh,
This is-
looks.
It's looking like that's some land there.
Yeah, it's also so that might be Africa, right? Because they will pass over
Then it's just
Africa
shadow of the
shortly before
clouds, isn't it?
re-entry.
Yeah, they just now got acquisition of signal with Mauritius. It seems like, oh, look at that. Look at the flaps. 117 kilometers, 16. We're coming down.
I'll tell you one thing, I would not
and
want
the
to be on
camera itself is just moving.
So I hope it doesn't stop like this, because this is kind of like the wrong side. You don't want to.
Yeah, right, right.
But it looks like
What are we
look, they have
observing here? We are
control.
Wiggling
seeing-
its flaps.
Yeah, right. They're moving those.
Wind
those-
Grace
those
blesses
things
the
around.
rains
You can
down
see
in
how it's feeling already the
Africa.
drag, because all of that ice coming down.
I don't think it
that
was
is
land. I
because
think
of
it was
the
just the
drag from the
clouds. I think.
atmosphere. It's very clear.
Well over the Indian Ocean.
And that's ice and not tiles.
Fascinating. This is honestly
we hope
Oh, look at
fascinating.
that. Actually, it is. It looks like they are trying to gain control here, huh?
Oh yeah, they have
Oh,
it.
look at that.
And now,
Yeah.
and now because
Wow.
of their
They've got it tiled
because
down
of their,
now.
if they
just
have the
about.
right orientation, now they can use their flaps. Like at
Right.
this point, once they are on belly forward, now they have the flaps to control this.
They're getting there.
Oh boy.
Now,
It
should we
just
see some
shows that
speeding
even in
soon,
the
too?
Look at
super
those
thin
clouds in the
atmosphere, what,
background,
106
yeah.
kilometers up, they can still use orientate
Oh,
with
boy.
the.
It's doing
There's
another
enough
turn.
Yeah, another
atmosphere
rotation.
there to use the flaps to orientate
So if
it.
it does a full one at not only 180
Yeah.
degrees, because that would be bad.
And it appears we did get some confirmation that this is actual video coming down via Starlink. And the reason why the camera is moving is it looks like the camera is on one of those grid fins there.
On
Or one of
flaps.
the fins on the flaps.
On
yeah.
flaps.
Yeah.
This is
a
one of the
flat cam, so
coolest
when the
things
camera
I've
moves-
ever.
Ooh,
This is one
Plasma.
of the
that
What
getting
is it?
red.
Oh, there's some
Plasma.
heating.
Plasma building up. There we go. 100 kilometers. It's coming through.
The wings are
Look at that.
glowing.
Never seen
Moonraker.
live
Oh,
like this. Oh my goodness.
oh, good heavens above.
Oh my god!
Wow, that's
at that.
spectacular. Is it real? It's CG, isn't it?
So far, so far so
Now
good.
then, is it just going to disintegrate
keeping the,
suddenly?
Look at that.
They're
But the
keeping that side down.
rotation.
Yep.
The rotation
And
is
that's part of slowing down
Yeah.
too, right? You want to make some
Yeah.
rotations
Come
here.
on.
Yeah.
I want
just
to
want to get
the
a
other.
psh.
Come on, chip 28. Come on. That looks. That's not the TPS side.
and the signal is holding steady, I guess.
Ah, Brazil's in the Atlantic,
How
not
do
the
they have
Indian Ocean.
signal still?
This is amazing that it hasn't gone out yet.
Oh, now they're getting it. Look at, they're turning it.
Look at that.
Ooh,
Oh
Just
my
wanna lose that
god.
camera here.
is it going
Wow.
to disintegrate suddenly?
I mean, can you imagine? I don't think
The
we've ever
flaps.
seen anything like this before.
This is the most
amazing.
insane thing I've
I mean, is it
ever
going to
seen.
survive? Is it going to survive
Oh my
re-entry?
God.
Oh,
Still
oh,
going.
camera's
Look
going.
at that.
Is it going to survive? Is the camera going to
How
survive?
does it still have signal?
They're all cheering. Ooh, made it through.
The heat shield tiles doing their work. We talked about it earlier. Up to 2,600 degrees Fahrenheit that those heat shield tiles are dissipating as we are re-entering.
Yeah, now this was one of the
Getting through?
critical, or rather the key
think-
Well,
mission
it's doing
objectives that we were
something at
hoping to
least.
hit.
Nope.
So it looks like they're doing kind of what the shuttle used to do, which is some maneuvering, right? To use some of that
Oh.
drag to slow down.
Is it?
Maybe.
Has it made it through? Has it made it
How are
through?
we still seeing this?
We're seeing things.
That's a tough camera, isn't
81,
it?
80 kilometers. It's going down, boys.
It's a tough
And it's
camera.
so far not like it looks stable. Do I dare to say it looks stable?
Uh-oh.
Speed is going down as expected.
And
Yeah,
what's
now it's
even-
fighting with the plasma.
Yeah.
Yeah.
And what's even crazier, this is a
Speed, my
completely
God.
automated process.
Yeah.
But you want the vehicle to remain stable. You want those heat
Come
shield
on,
tiles
Chip
pointed
28. You can do
down.
it.
Look at the orientation.
Grab it
So
now.
they
Has
can
it
absorb the heat of the
disintegrated?
Earth's atmosphere.
Oh.
And so that's the purpose that they are serving during the
As long as
hypersonic phase.
They're
coming
still getting
down,
telemetry
means
from it,
it's
though.
At least transmitting data.
Yeah.
It's
That
just
should
the
stop.
video
If
takes
it did.
a lot
Oh,
of bandwidth,
right.
and so video may cut out.
Right.
much
Oh, no,
more,
we're still
Right.
getting telemetry.
likely.
Oh,
But we're
So
seeing
it's
that
still,
graphic.
they're still getting
moving
signals from it.
quite a bit.
It's
That was
moving.
And
funny.
it's
now
yeah,
slowing down
side
quickly now.
Yeah.
On that telemetry.
that's a bit of a violent turn there.
Yeah.
Yeah. Whew, boy.
But,
This is
but
fucking
it's
exciting.
turning still.
Yeah,
It's turning still.
That little fella inside's going,
It's doing what I could have
"Ah,
expected when I said before this launch. I said, I think they're going to get some kind of line of data you can see now is slowing down even more. You see that the speed is going down faster, the altitude is going, because the peak heating is towards the end
Uh-oh.
of the entry.
We lost telemetry now. The numbers have stopped.
And also the fact that they're getting some data here, although it may have cut off at this point. But I would imagine what we just saw and that buildup of plasma, and they've got some tiles they're holding up here on their desk there. That buildup of plasma and the heating and the visuals that they acquired here are something we've never seen before. And I would imagine that's going to be very informative for future missions of Starship to just see what forces
like
are
it's
out
broken
there
up.
and how that interacts.
Telemetry
Here's a scene
lost.
from the launch complex. It looks like the
Same little fella that
launch,
works in every
mount is
vending
still in
machine.
good shape.
Yes, it is. Well, it's related to
Yeah,
him.
so right now they're basically in a blackout phase. But once you have so much plasma building up,
It's a
and
race of
everything, you will have a
people
blackout
that
phase.
just
The
do
question
stuff
is,
like that.
are they
Operate
acquiring
our
signal
machines.
again after the blackout phase? Because that would mean the ship has survived re-entry, kind of. They expect the transonic milestone around 1 hour and 2 minutes.
Okay,
Yeah.
so not too much longer here, so we'll see what happens. So we're waiting on it. It's possible we will never hear from it again. And one way or the other, if it does survive, it will be entering the ocean pretty much in a full-on
either way.
belly flop. So this is the last moments of this particular Starship, although it served us quite well, I think, this time. I mean, what an amazing set of visuals we just had.
It is.
And that was
completely bonkers. Also,
Let's
completely bonkers. I'm continuing the segues here.
See if they're saying
this
anything
shot
on
by-
there. I'll just get rid of that. We'll see what they're doing on the. Where are we? Where is it? Spadosh.
The flaps are protected by the flat heat shields like I have. There are 4 of those positioned on Starship.
Where are we? Are we live? I can't tell.
And 2 at the bottom.
Just bear with me.
And they operate independently to aerodynamically control the vehicle's attitude or positioning during atmospheric flight and enable precise landing at the intended location. So today we are intending to splash down in the Indian Ocean. And we're hoping that we can make it that far, but regardless, it is an exciting end to what has been an exciting day.
Absolutely. And I mean, we've had some tests in the past. We had suborbital campaigns where we have tested out the aerodynamic flaps at subsonic speeds. So that's below the speed of sound. At hypersonic speeds, well, supersonic speeds first, so faster than the speed of sound, and then hypersonic speeds.
If these
so
numbers
that's
start
more than
changing
5
again, the
times
ship
speed
will
of
just
sound.
emerge.
The equations of
And
motion
everybody will go,
change,
"Yay!"
how the vehicle
like in
responds
films.
changes. So going through that control phase where we're going from
And it'll
faster than
land
the speed of sound
softly
to
on the
below speed of
Indian
sound was
Ocean.
one of the objectives today.
And the little
That's
fella
actually
will
a
get
great
out.
point, 'cause
He'll
we
open up
are
the
expecting,
cargo thing,
that entry's subsonic
payload bay,
period
and they
to
get out and
occur
just stand on
around
top of the
T+1
starship
hour,
going, "Yay!" and then a
and
shark will
3.5
eat it.
minutes. So we're not there yet. We're about 10 minutes away from that point. So again, that is when Starship would be traveling slower than the speed of sound, thanks to the atmospheric braking system.
What if you're doing the exact speed of sound? Are you just sonic?
And so right now we're still waiting to see
Spinning
if we're gonna
right
get
fast,
data
little
back
blue
from
egg
the
jog.
ship. We might be in a bit of a blackout period right now. So still waiting to hear the status on it. But yeah, we got to the actual entry portion of today. We started into peak heating, which was just a really big milestone. Starship is pretty unique in the way that it re-enters, especially for something reusable. The closest parallel has been the space shuttle. When we're comparing Starship to like when we bring a Falcon 9 booster back, we're talking about 20 times the energy given the velocity that we're moving at, and all of that energy just gets converted into heat, and then we need to use those tiles to just help dissipate that heat. They're not ablative like you would see on something like Dragon, which uses an ablative in the capsule shape. So they are these tiles that are made to be reusable.
Is that the green screen? Is he
any
actually
data we're
sitting there?
getting
I
on
don't
the
know. I think he
actual
might. I
temperatures
think he
that
might
we're
actually
seeing
be
during
there in.
heating, all of that is just really
Looks like he's
hugely
in one of
valuable.
the big
Where
buildings
Starship
at,
is really
at
unique
Boca
is,
Chica,
and
doesn't it?
Kate
Mega
Shiva
Bay.
talked
Is he
about it a
Mega
couple of
Bay?
times, is once we're
Could be.
through this kind of hypersonic section,
It might
and
be a
we get
green
down
screen, I
to
don't
the
know.
subsonic, and that's where we really learned a lot and proved that Starship's really just its basic shape could work, and we did that during the suborbital campaign. Again, if you compare it to the shuttle, which entered, it had the wings, it had a similar heat shield system, but it had wings, and then was almost flown like a glider once it re-entered and was down to those subsonic speeds. With Starship, we're not doing that. We're just coming straight down. We'll hit terminal velocity, which with Starship is around 200 miles an hour, and then we use a flip maneuver to ignite those engines, do a landing burn, and then touch down on the ground. So you don't need a runway. We're doing that, again, designed because when we go to the moon, when we go to Mars, there's not going to be a runway there for us. And so that propulsive landing is going to be really important.
External view.
Of pretty much what we were just watching on actual Starship video, which is pretty incredible. But we go through peak heating. One of the benefits of today's trajectory, actually, we got closer to what the heating profile will be on just a normal mission when you compare it to our previous flights, which were headed out to Hawaii. So we go through peak heating, and then we hit subsonic, and then Starship splashes down in the ocean. Again, we're not doing a landing burn on this flight, and we're not expecting Starship to survive the impact. We're not going to be recovering any of the hardware. For now, though, we are just still waiting to see if we're going to get some signal back. We're currently at a loss of signal with Starship. Don't know for sure what its status is, and so we're just continuing to listen in. But it was pretty incredible seeing the flaps really do their thing to maneuver the vehicle as it's moving through hypersonic. One of the big trade-offs between something like Shuttle and Starship is wings can be pretty heavy. And so if we can really demonstrate that Starship's controllable through that hypersonic regime when you're coming through the atmosphere, 25 times the speed of sound, you can save a whole lot of weight by not having really big wings. So super valuable to get this data, super valuable to then figure out what we're going to do on our next test flights.
Dan, you'd brought up a really interesting point too, that for on Shuttle, you are gliding in, going back to a runway. On Starship, because we're landing vertically, we are basically coming down, and then we've seen this during the suborbital campaign. We're not going to see it today, but during the suborbital campaign, we did the flip maneuver and then light our engines for a landing burn. And that's also really important for some of our other terrestrial destinations. That we don't have as much of an atmosphere on Mars. There is pretty much no atmosphere. There's some great views from our previous test campaigns of a landing burn and the upright landing. But on the moon, there is no atmosphere. On Mars, the atmosphere is extremely thin, so you actually need some other sophisticated techniques that other landers have used to land there. And so this vertical landing technique is really important to landing on destinations like
cool
those,
if you just saw it land the chopsticks catch
so
it.
we hope to demonstrate
back at Boca Chica. How did it end up out there? Don't
future
know.
missions, that wasn't one of our objectives for today. We wanted the ship to focus on opening and closing, the first demonstration of opening and closing the PEZ door, which is where we will deploy Starlink satellites from in the future, as well as a
Because it's orbital or
gathering data on how the heat shield
Van Allen
tiles
belt's
performed
way out
during
there.
the entry period, and so far all of that has gone really well. So overall, it's been pretty
And going
great,
to the moon, you
and
pass
it's
through
great
it
to
really
see,
quickly.
how those initial tests that we performed a couple years ago for those high altitude tests allow us to see what those will look like in the future. But this piece that we're doing today of, okay, if we are coming back from orbital velocity and we're going through that entry period,
when they go into the moon, they
missing
pass through the
piece,
Van
right?
Allen
We already
belts
figured
really
out how
fast,
to
don't they? So
land
it
once
doesn't
the
really
ship gets
affect
to
them. They get
a
a
certain
higher
velocity or
radiation, but
altitude,
nothing
and
that's
it's really this
life-threatening.
piece that we were
Because
trying
we've
to figure
seen
out
it, haven't we,
today.
of the Apollo
How do we get
astronauts?
Starship to
Because they
survive
did go.
orbital velocity atmospheric entry, and we hope to find out soon.
Yeah, I mean, we talked about rapid iteration and how we do design. Part of our
And plus
philosophy
with,
is
you
testing
can
early
orient
and often and trying to
the
test
craft,
in a way
can't
that
they?
is
So that
as
the
flight-like
more
as possible. But there's
shielded
only so much
sides,
you
like
can
where the
do
engines are and
in a
stuff,
chamber
they can go
where
that
you're trying
way
to
forward,
laboratory in the
can't they? So it
atmosphere in a,
shields the crew from
exactly
the
in a
radiation and
laboratory.
stuff as they're
So
passing
there's
through.
nothing quite like when the heat shield tile hits the atmosphere in flight. to gather that wonderful data and prove out some of the analyses and probably teach us a bunch of things that we didn't quite get right.
For sure. And obviously, for those of you that have been watching along with us, those were incredible views to see of that entry period where we saw the heat generating because of friction. As
Did she say Saul then? Is she
belly
from
of Starship
Philadelphia?
was, making contact with the Earth's atmosphere, and that
So they
resulted
say
in some
Saul and
plasma. So
Jaws
as Dan
and
said
stuff, don't
before, we believe that we're in a bit of a blackout period at the moment. We are
I prefer
expecting the
radiation
vehicle,
suspenders, to be
if
honest.
it's still alive,
No idea what that is.
we would be expecting the vehicle to be approaching
I'm sure it's
subsonic
dirty.
or slower than the speed of sound speeds in 3.5 minutes from now. So if it's still up there in one piece, it still has a way to go. We're not there just yet. But we saw that plasma field building up around the exterior, which can blanket the entire vehicle, as it does with all of our Dragon missions, and we're at a loss for telemetry at that point in time. So
Dan's seen a lot of those with Dragon missions that he's supported.
Yeah, absolutely.
Okay, very good. I'll see myself out.
And we are hearing through some of the
Start the engine.
It did look like we lost Starlink and our TDRS data flow at the exact same time. Now, if both of those signals are cutting out at the exact same time, that could mean we lost the ship. It has been several minutes since we've gotten any data from Starship. We are waiting just a couple more minutes just to see if we can get any additional confirmation, but that is one data point that we're tracking, and that could indicate that we had a loss or a breakup of the ship during that re-entry. So might not make it all the way to splashdown today, but we were able to get through.
By the way, we
the
call
early
them
phases of
braces,
re-entry, hit some of that
suspenders.
peak heating,
No, you call them
which was
suspenders.
just
We call
really
them braces.
incredible to see a
Hold your
Starship
trousers up.
coming back from
Or your
space
socks.
after getting all those views from space for the very first time.
Suspenders,
so
what
we'll
women
just
have on the
keep on
tights
listening
over
in
here.
on the
That's
loops here, see if we
sexy
hear
suspenders.
anything over the next couple of minutes, and that might bring a close to a pretty successful day so far. So again, we did lose the TDRS. That's the tracking and data relay satellite. That's the satellite system that pretty much every spacecraft operating in orbit right now will use.
So if we don't get any
data.
more telemetry
we were able to get
down
some
here,
signal
when it gets to
through
like
that.
103, we know that
And
the
then
ship's
we were also
broken
getting
up.
data back
Which it
through
probably
Starlink.
has, to be honest. The way it came coming down.
Live view here of mission control down at Starbase. So these are all the folks who are experts on the various different systems, taking a look at the live data that we did have. Probably in mission mode still.
What if anybody's
but
playing
absolutely, It
Gallagher?
would be so tough to stay focused with what an exciting day we've had today.
Yeah, to quote Monty Python, I'm not dead yet. We don't know, as Dan said. We did lose connection with TDRS, which is the tracking and data relay satellite system, and Starlink at the same time. So it is a realistic possibility that we lost Starship, which honestly was always on the table. We didn't know how far it was going to get. The further we could
This was
fly
all
and the
cool.
more
They have to
data we
bring
could
some whales
collect
back.
was always the
Yes.
biggest win. And so regardless of
Humpback, sir?
if we did
People?
lose the vehicle and we are not
Whales,
able
Mr.
to
Scott.
make it all the way to our intended splashdown, note that we weren't intending to recover this vehicle, either vehicle, the Super Heavy booster nor the Starship. We weren't intending to recover either of them. They were both going
3.9
to
million people are watching this now.
basically hit at
There's
terminal
3.9
velocity and
million
break
views.
up upon contact with the surface of the ocean. So we're standing by to hear whether or not we are going to be able to get telemetry readings back, but we are possibly anticipating news that we lost Starship due to basically a double blackout from TDRS and Starship data at the same time.
But this is, it's worth mentioning, this is the first time that we have come back at these speeds
Absolutely.
in any of the test flights that we've done so far with Starship. So we are trying to prove out that the heat shield works as intended, that the controlability at those hypersonic speeds works as intended. So if we were able to get back any data on that, that means the next version, what happens on flight 4, 5, 6, is going to be better.
And we must be able to get some because we saw incredibly gorgeous high definition views of that entry period whenever it was initially starting. So We must have gotten some data
today
there.
has been otherwise a phenomenal day.
Incredible.
Liftoff on time, full ignition of all of the boosters, engines, successful hot staging, and then ship took it from there.
Yeah, absolutely. We were able to see the ship actually make it further as well as the booster. We were hoping that the booster would perform a soft water landing, but we lost it during just before it was able to ignite the landing burn. But the ship continued on. We saw all six Raptor engines on the ship ignite and then shut down for second engine cutoff. And we saw some amazing views as well, and it's just been certainly a day that I will be taking.
Looks like they're
many
getting ready to wrap it
screenshots
up, doesn't it?
And using them as my computer desktop background for, well, until the next Starship launch.
When we get even better views, I'm sure.
Exactly.
And we also hit a number of our other ambitious test objectives. We had a chance to at least initiate the commands for a propellant transfer demo within the vehicle. This is something that Starship's going to have to do in the future, and these sort of transfers haven't been done at this scale before, so that's a first as well. We also were able to demonstrate that the payload door.
And I bet over the next few days we start seeing footage of it coming in and breaking up. Someday, even though it's in the middle of the Indian Ocean, there'll be somebody with a camera somewhere on a ship or whatever, hundreds of miles away that'll have seen it. There'll be somebody somewhere that's
a number of test objectives
filmed it with the phone.
Much more accomplished than Flight 2,
Bet there is.
and making steady progress towards a fully, rapidly reusable,
Or from an aeroplane or
reliable
something.
Starship.
Absolutely.
And hey, Kate, and hey, Shiva, we were just hearing on the loops, we are making the call now that we have lost Ship 28. So, as we were possibly expecting, we lost the data a couple of minutes ago. We haven't heard from the ship up until this point, and so the team has made the call that ship has been lost. So no splashdown today. But again,
I'm sure bits of it are splashing down.
Further we got this time around.
Just not
we
in
had
one
a couple
lump.
of those ambitious objectives that you guys were just walking through that we're able to take advantage of while Starship was in outer space flying over our planet for the very first time. So that was just really incredible. Obviously, there's a lot to go through. Everyone always wants to know right off the bat what happened. Takes us a little bit of time. But I can assure you, as soon as we start finding things out, we're going to let everybody know. And I know everybody's going to be excited for the next one. I mean, as I pointed out at the beginning, there's 4 super heavy boosters either fully stacked or getting stacked right behind me. We've got other ships ready to go as well. So it's going to be a really busy time down here at Starbase as we look to really fly Starship as much as possible, get this vehicle ready to go for all the important things it's got to go do.
And with that, we got to say a huge congratulations to our teammates and everyone who's supported
Yes,
the Starship.
they're finishing off, are they? Right, let's go back to them. What are they saying?
So that's definitely quite
Right.
amazing
So,
thing that you can,
there we
you can
go.
grab as well.
The Starship. SpaceX has launched the third fully integrated Starship. The ship was lost during re-entry.
On your devices
But
of
it was
choice.
pretty spectacular, wasn't it? Pretty spectacular.
It looks like I'm able to get some questions in here from the audience. Here was a question from Doug Van Dorn.
Right, we'll leave it there. We'll leave it there. Remove. There we go. Right, so that were cool. That were cool. Let's go back and watch some of the where did it launch? Let's just go back and watch some of the footage. Where are we? Not that far ago, was it? It was down here somewhere. Here it goes. Right. I'm still on 10 minutes there. 3 minutes. I'm going to watch the launch now. We'll watch this, and then I'll turn it off. We'll watch the launch again. Pretty spectacular. You see the deluge thing go at the bottom there. All the water sprays in to, stop the flames from basically melting everything or destroying everything. It's instead of a diverter, instead of a flame diverter, they have a deluge system. So off it goes, all 33 Raptor engines firing as it heads up into the heavens. Cool. And then it did its separation. It's done that, hasn't it? It's separated now. It's separated and then did all its cool stuff. The booster, I don't think... Oh, we can't... Oh, no, because I didn't bloody put it up, did I? I didn't put it up, did I? Never mind. The booster came down. I don't think it slowed down enough, did it? Because it seemed to smash into the sea. And they lost the Starship as it re-entered. But they didn't do the... Yes, I know. Not seeing anything. I know. I forgot to include it. Doesn't matter. I'll show it again. All right, we'll go back. Where are we? And I forgot to add it to the screen because I'm an idiot. You all know this. Right, off we go. Right, there it is. Right. I know I'm stupid. Right, you can see it now. We're going to watch the launch again. There's Starhopper in the foreground. Princess, my cat's jumping up at the window. That's the tank farm, tanks with the propellant in. There, off it goes. We had the deluge system, and then up all 33 Raptor engines ignite. And as they said, they release the clamps way before launch, don't they? So it's just standing there under its own weight because it's not windy. Off it goes. All those engines and the shock diamonds there, sometimes called Mac diamonds. It's what they call it, an interference pattern, isn't it, from all the engines. Oh, thanks. I missed this part while coming into work. Oh, there we go. But anyway, here it goes. Off it goes. It is spectacular, isn't it? And majestic even as it soars into the sky. Into the big blue. Azure. So I'll just leave it to play. If Josh didn't see it earlier on, I'll just leave it to play then. I won't try and get the highlights. We'll just watch it again. With no sound. Off it goes. And then, I don't know, it's about 3 minutes in, it'll, the Raptor engines will cut off on the booster, and it'll do its hot staging, where the Starship ignites its engines. It's three, does it ignite all of them? I can't remember. We will see. Oh, there we go, it's showing us there. All 33 Raptor engines are ignited there. And then soon they'll shut off. And they'll do the hot staging where the Starship ignites its engines and just basically just blasts itself away. But I didn't see any tiles coming off. I mean, there's little white patches, but I think they might just be, ice and stuff that's stuck to them, maybe. Or there could even be labels, I don't know. I actually thought something was going wrong at one point because it seemed to go at a funny angle, but it was fine. What do I know? Obviously, it's not moving it's not moving sideways. It's the clouds that are moving, and there because the engines are cutting off now by the looks of it. Or in a minute. Remember the SpaceX feed is a bit behind the NASA spaceflight feed, so we'll probably see the engines cut off. There we go. They're cutting off now. Look, and we'll see the hot staging. Are they going to show it? Are they going to show the hot staging? Or did they miss it? Did they miss it? Because they're idiots. Too busy looking through their own cameras. Never mind your own cameras, SpaceX. That's it. Go to that. Oh no, it's still going. They've got they've got some the middle engines are still going. Oh no, it has. They've missed the stage separation, didn't they? They missed the stage separation. Because now we've got the middle engines on the booster as it's going back. Technically, it's not going back. It's in a parabolic arc, isn't it? But and the Starship is on its own now, by itself. There you go. That's the view. I think have they got these the wrong way around? I'm not sure. That's the booster, isn't it? Because it's got the grid fins. So we'd have them the other way around, shouldn't they? Should have the booster on this side and the Starship on that side, because that's where the rocket graphic is. This is the booster coming back. Oh, it's coming back down now. Oh, it's going back up again now. Oh dear. As I said, it's a parabolic arc, isn't it? It'll start falling back down. Oh, no, it's coming back down now. It's just speeding up, isn't it? As it's coming back down. As gravity grabs it. And this is there. They've swapped them round now. This is the Starship part. Still accelerating up into orbit. Even though it doesn't achieve orbit. It gets to orbital altitude. And velocity. So there we go. And then it came back down and we lost. Is it going to? Where are we? Where is it? Oh, this is it, isn't it? But it shows it coming down. It's like getting faster and faster, and it doesn't seem to be slowing down enough. So they must have footage of this, because this is quite near, isn't it? Quite close to, where it took off from, within a few 100 kilometres, miles, whatever. And it seems a bit out of control. Them grid fins are struggling to control its attitude, aren't they? Altitude 1 kilometre, no kilometres, landing burn, splash, dead. I bet that looks spectacular from outside. Surely somebody must have seen that. But and then the Starship carried on. It did its tests of its hang on, where are we? Of its payload bay doors. Is it going to show it? No, we've gone past that bit. It tested the payload bay doors. It opened and closed them. It did a fuel transfer test. I'm not sure if it did that, but they said they sent the signals to initiate the fuel transfer. I don't know if it actually did it. And then it started re-entering and looked all spectacular, thusly. And then at something like 70-something kilometres, we lost the signal. It must have broke up. And I bet that looked spectacular as well. There we go. There, the grid, the fins on the ship. Does look cool. Right, so we'll leave it there. So sadly, it's lost. I don't think there'll be will there be a huge investigation? FAA investigation again, like they did with the previous two. Or hopefully, we'll have a shorter time between the next launch. I hope. We'll see. Hopefully it'll be weeks rather than months. Because we're November the last one, and now we're in April, so it's like 5 months, isn't it? So hopefully it'll be less than that. But we will see. But there we go. That's coming up on losing the signal. That's it, isn't it? I think thereabouts. So there we go. Cool stuff. Amazing stuff. Right, going to leave it there. So thanks Josh Temple and Win Grace and Laura for popping in, keeping me company while I get excited watching a rocket launch. It were cool. It were amazing. It were better than cool. It were amazing. And, probably did more than they wanted it to do. That's what they usually say. But next time, I don't know, will we see it make it to Hawaii next time? Space. Hopefully it'll make it to Hawaii next time. We'll see what happens. I don't know. I don't know. It was a great time. Glad I checked in, said Josh Temple. Yes, thank you. Like to see this stuff because it's been a long road getting from there to here. Sound just like Russell, what's his face? Watson. Right, we'll leave it there. What's coming up? What day are we on? It's Thursday, isn't it? So tomorrow night, I'll be back with my Friday night appointment with Thea. We're doing Jeepers Creepers 2. And then next Monday, we're doing Warlords of Atlantis for Magnificent Mondays. And on Sunday, I'm doing another sketch stream. Right, so there we go. Wingus has claimed. Have you got in your boat out to the middle of the Indian Ocean and claimed the debris in international waters? Anyway, right, we'll leave it there. So, thanks for watching, wherever you are. Look after each other, and until next time, I'll say thee.